paper and he's on wheels.
Okay.
I don't know.
All right, everybody. It's time for the new in-person once a month meeting of the Robotic Society and the joint club with Riverside. We are in our new location at the Acoustic Long Beach with all of our members here that usually come to our in-person meetings. Again, we are at a new building for those of you guys that wanted to come and are looking for it. We are in the Beach Building Services building. It's right next to the old building. Starting with welcome. This is the new in-person meeting. We are gonna have 2 lectures today, starting with Alan Tim. He's gonna give us a presentation on his new project that he's working on. After that, I believe Jim, you're gonna give a presentation on his new Orange, all of his awesome progress that he's been doing with Orange. And from there, we're gonna take a small lunch break, a business meeting, and there's some show and tell. So if anybody else have any questions or comments, let's get started.
All right, so welcome everyone. So I want to share with you some things that I've been working on. There's this whole side project where I'm converting a 1980s robot toy to be the toy I always wanted it to be. And one of the first things that I need to do is to be able to, control servos, neopixels, things like that. The Omnibot is going to have a Raspberry Pi 4 on it. And that can be used either for direct processing to have a brains on board type situation where there's no external processing, or it could be used as a conduit where it collects all the data and then it passes the heavy lifting off to a computer on my desk or at home to do it, and everything in between. So when you move up into the bigger iron, so to speak, in computers and Raspberry Pis, a lot more processing power. You can do visual stuff, deep learning. But one of the things that they're not great at is directly interfacing with peripherals. So all that experience that you've built up with Arduino and Teensy still comes into play because you're going to leverage those microcontrollers to facilitate that low-level communication. So I'm going to share my screen really quick, and let me show you where we're going to end up. Sharing right now, optimized for video. And so just in case I had any technical difficulties, I grabbed a quick video clip of the demo, but it's also running on my desk. So during break and during show and tell, if anyone wants to take a closer look, it'll be here. But what you're looking at is a quick and dirty setup. I spent about a half hour last night writing a quick node that lets the joystick communicate with this I program. So it controls 2 different things. There's one button that controls the brightness of the NeoPixel ring up in front. That's what you're seeing me press on right now. And the left joystick controls the XY for the eyeball. And so this is a ROS2 project. I'm finally doing a deep dive and letting go of ROS1, which is not without its challenges. We'll talk about some of those today. But at the end of all of this, you have a reusable component that takes care of handling the messages for the servo positions and the NeoPixel ring. And then you're free to write the rest of the code to do something interesting. All right, I'm going to switch over to my VMware. So while we're getting started, funny story. I do a lot of work in VMware. I've been using Linux for years. My work laptop is Windows only, so I set up a VMware virtual machine with Linux on it, and that's why I'm able to give the demo and stuff today. Something awful happened between VMware and Windows 11 over the past few weeks, and VMware runs super slow right now. So in the demo today, you'll notice a little bit of a lag until they sort out what has stopped working so well between VMware and Windows 11, things would be a little bit sketchy. At some point, Jim might give a quick talk or a demo of a magical little feature of Windows 10 and Windows 11 called Windows
WSL, Windows Systems Subsystem for Linux.
Windows Subsystem for Linux. It allows you to run Linux as a container in Windows as a first-class citizen, which negates all this VMware stuff. The one thing that I couldn't do under WSL that I can do under VMware is WSL does not currently support USB and serial ports. So I couldn't, without access to the serial port, I couldn't continue the demo, but it is super cool, and I'm sure they'll add it on at some point.
Serial ports and what was the other?
And USB apparently.
Oh, which is the serial?
Peripherals,
Oh,
yeah.
it doesn't do, okay, that's unfortunate.
Yeah, so when, let me go ahead and move this over. So again, look, talking about how things are going to end up when it's done. We have a series of programs which Ross calls nodes. So they're just little programs sitting out there doing their thing. And they communicate with other nodes, like this quick script that I wrote in Python that takes the messages that are pumped out from the joystick port and pushes them out over these three topics or messages.
Someone's not needed, Thomas. Thomas, can you please mute your mic?
Sorry about that. To complete this demo, I'll go ahead and move this out of the way. Let me switch out of video sharing mode. It might be a little bit less laggy. Just a moment.
Hey, Alan, is it similar to like teleop, what you're doing with the joystick? Or did you have to write your own? You have to write your own joystick kind of driver node.
Well, and that's the beauty of ROS. Like I've always said, once your problems, the things you're trying to do, are large enough to require ROS, once you get used to the ROS framework, you get to take advantage of all of the tools in the ROS toy box. And in the ROS default toy box, when you install it, is a joystick node, a joystick controller called Joy. And there's documentation that I'll pull up in just a minute that says how to launch it, the type of messages that it provides, and you get it for free. So then all you have to do is know how to accept those messages. And in 30 minutes, I wrote a quick, again, skipping ahead a little bit. Wow, that is super small. A quick program that takes in the output from the joystick node, and then it spits it out to the eyeball node that's running on the TC to make it run. All right,
And
so,
you're using a standard like joystick that is serial.
yeah.
So
So
wired serial.
yeah. So a quick demo in the room. And it all just works. And there's also a camera in there that's attached to a Raspberry Pi that in the, further on will be used for image capture and passed on for some artificial intelligence stuff. So the question is, so how do we get there, right? And it's unfortunately, it is a little bit more challenging than back in the ROS 1 days. So I'll do my best to kind of map out how I solve for it. It was a good weekend of putting together disparate information, somewhere between treasure hunt and frustrating waste of time to get all these things to work together. But once they work together, they just work. And one of the things that I want to kind of talk you all into is that if you're currently writing code on the Arduino IDE, if you're using it for your Arduino or for teensy other projects, I want to draw to your attention this amazing open source platform that Microsoft released called Visual Studio Code. It's kind of Visual Studio's kid sister, or kid brother. It is open source, meaning the code is available, and it has a rich extension system that people are taking advantage of. And so I'd like to give you a quick look at why you'd like to switch.
By the way, control equals will make the font bigger
Oh, okay.
in the code.
Oh, very good. Thank you. All right, so I think I have it installed here. Okay, other screen. All right. So I installed Arduino just for this demo here. Let me go ahead and bring it up and bring up a copy of code. Oop. And so one of the first things you do when you load the Arduino IDE is you look at the example programs, and then you compile them. So on the control
Equals on your, or,
there we go. All right.
or does it work on that too?
Yeah, it does.
That's pretty good.
Yeah, because that's a Microsoft thing I discovered for like Visual Studio.
Oh yeah, no, the half the lights are
Control minus goes the other way.
minus. And so you've got, these functions, you learn about setup versus loop, and there's a pin mode thing and a digital write thing. And when you're typing out the code, like if I wanted to take advantage of the pin mode function, it has a little bit of highlighting that says, oh, I recognize that word, but it doesn't tell you anything about how to use it. You don't know if you've used it correctly, or if you have a typo, if you forget the semicolon, until you hit compile. A little bit of a lag here. There we go. You can focus on my screen and not the projector. And it's only after you compile it that it's like, something's wrong, and you get to sort through the messages on bottom. So let me show you how this is handled under Visual Studio and Platform IO.
Yes.
And so once everything's loaded, you can grab a project example. And there are a bunch of them. There's not a lot, but we'll grab the Blink example just for demonstration purposes. And I'll increase the font here in just a moment.
He's importing and then going into this studio.
Yeah, it's Platform IO. Yeah. There's a whole menu. There's a menu for that stuff, right? The library. Yeah, the Platform IO. You can import. It's right there. Import with the menu of things you can do. The Platform IO.
Yeah. And in addition to all the other benefits, it supports a dark mode, something I believe strongly in. But if it's not your thing, you can make it look normal. But check this out. And you've got the same setup, and you have the same loop structures. It does pull in an extra header file, which is just a convention under Platform IO. But watch this. As I go in and I start writing code, because Visual Studio Code is an intelligent IDE, it knows all the libraries you've pulled in. It sees the definitions. It sees the things that you've defined. It can intelligently tell you if you're on the right path or not. It doesn't tell you if the code is going to do what you want it to, but it will give you feedback as you're typing code that the code is syntactically correct. So as I type in pin, it's like, hey, here's everything that I recognize across the entire, TZ library base that matches those 3 letters. There's some pin definitions that are used somewhere deeper down. But let me go ahead and click on pin mode just to autocomplete. That's handy.
Like the old Visual Basic.
Like the old Visual Basic, yeah. Let me do a left parentheses. And then right above it pops up exactly how it's used. The variable names say what they're for. They say the style. And the first thing I need to define is a pin, and I'll just make up something, pin 10, for example. And the mode. I can't remember what the mode
So that
is.
light bulb, if you click on it, it will give you.
Mhm. And if you mouse over it, it gives you some more hints about what they do. And this is all available for free on Visual Studio Code. And unless there's a lot of old diehards that have, that have worked in this long enough that they've memorized all, and that is fantastic. But I'm a dabbler. I'll code in this for a little bit, and then I'll move back over to Python. And my storage space isn't as deep as it used to be. But having an IDE that helps you remember and understand how these things are used is amazing. And I can't see a reason to go back.
Nice.
Now, I was just on with the Arduino Raspberry Pi Club of Costa Mesa. Well, that's where they used to meet. And I was pitching this to them, and they're all diehard Arduino IDE users. And so they were like, well, what's the benefit? And I told them kind of what you did. And then they immediately said, well, I tried that 3 years ago, and it tried to pull in all these libraries when I only wanted one, and it messed me up. And anyway, I guess it may have gotten better since then, but there's some level of integration with the pulling in libraries that might not be as smooth.
I
Supposedly.
guess for like an application where you have very limited storage space, the extra libraries might come into effect, or is gonna.
He didn't want them. He was like, it was
Yeah,
messing him up.
So if
I don't
you
know.
only have like a certain, certain space that you can use for your code, like whatever, very limited in storage.
Exactly, yeah.
Yeah, extra libraries that you're not even gonna use, that's gonna.
He was trying to update, and it updated, it's an update situation. He was trying to update a single one, and it updated this whole slew instead, whereas in the Arduino IDE, you could tell it just that one, and hopefully I said, if you see that, you submit a ticket. I do that for any company. If I'm using it, I'll submit a ticket saying, hey, this could be improved. But I have no idea if it still does that problem, but just your mileage may vary.
Yeah, for sure. Yeah, Dan.
Well, I was thinking, what if you use this first and then copied it and then put it into the IDE? Then it wouldn't have all the extra.
Well, yeah, and you could, the code itself is interchangeable. This include Arduino each even works just fine. It's just implied on the Arduino IDE. But there's no point, because you can compile and upload right from here through platform.
Yeah, you do everything right from here.
Oh, so you don't need Arduino IDE at all?
No, you could just I just leave it off. I use this, did sample code, uploaded, played with it, changed code, the whole cycle.
And then when you plug your cable into your Arduino, it recognizes it,
Yeah.
loads it. And,
It's got the same features.
Yeah.
You,
a plugin for code? Yeah, and I'm gonna walk you through exactly how I set this up in case you want to follow along. And even if you're not gonna go with the, ROS 2 teensy staff that I'm demonstrating today, even moving your code development over to Visual Studio Code and Platform IO is a huge win. Now, to be fair, there is one thing that the Arduino IDE does out of the box, just a little bit better than Visual Studio Code. And that is, if you're just getting started, it does have a rich set of organized examples to show you how the functions work. And the depth of examples that you have in this product aren't present in code, but the code is available on the Arduino website, and there's just a Google search away. But in the discussion about better or worse, my opinion, even if you're just getting started, Visual Studio Code is the way to go for that rich IDE and auto completion. And even if you're looking into something like, for instance, I wonder what's in this Arduino.h file. On the Arduino IDE, you just have to look for it in File Explorer. But because it's intelligent and it knows where you're pulling it in from, all you have to do is click on it and go to definition. And it's an include that includes two other includes. I wonder what the pins Arduino does.
I'll tell them not to listen.
And so you can search the includes in the other code files really easily. And this is the way coding should be. Coding is always going to be a challenge. It's very specific and very exacting, but to have a user interface that knows the syntax and is able to share with you the details of what you're doing is light years and so much easier than throwing code in a compiler and trying to interpret the error messages. Let the IDE help you with that. It's a partnership. Good, yeah. So that's my first pitch. Visual Studio IDE. One of the first extensions that you're going to want to install is an extension called Platform IO. The alien is their icon. They support oodles of platforms and frameworks. They have an extensible set of built-in libraries. And it does all kinds of great stuff. You know, in the spectrum of, you know, starting out with the idiomatic Arduino code and going to the, I'm going to handwrite assembly code. Now, this is a little bit further along, but you can write idiomatic Arduino. You can write full Arduino code in here, which is, you know, it provides shortcuts and templates and functions for, it hides the complexities of a lot of stuff you want to do. And to install it, once you have the code installed, is on the left-hand side, there's this extensions button. You just do a quick search for platform IO. Oh, you have to spell it right though. And it takes a few minutes to pull it all in, and then you're good to go. Once it's installed, you've got some action buttons on the bottom to compile the code, to upload the code, to clean the code, to open up the monitor, just like you do in the Arduino IDE, where you've got verify, which is compile, upload, etc. And once you're in the platform IDE and it's installed, you get a new little alien icon over here, which brings up a menu of stuff. Clicking on open, you can create a new project, give it some name. And you can select from a whole bunch of boards. So I'm using the Teensy 4.0, so I'll type in Teensy. And you can select that. If you're doing Arduino work, it supports it perfectly out of the box. You just have to select the correct Arduino.
So it has a bunch of organizations.
And it supports a lot of them. So Arduino Uno is in here somewhere.
That's where.
The newer stuff. So I'll go back to Teensy. And there's two frameworks. We're not going to talk about the RTOS stuff. We'll just use the Arduino framework to take advantage of idiomatic Arduino and hit finish. And it automatically pulls in the required libraries and headers and sets you up. The first time you do that, it takes about 2 or 3 minutes as it downloads all of that Arduino IDE stuff. Oh, we do have people in here. All right. Did his robot run over people? There you go.
Going around the building or around the building. Yeah. Oh, is it required that you guys do a survey?
All right, so that's step 2 of our stack is Visual Studio Code, Platform IDE. It supports oodles of boards. We'll be focusing on the TNC 4.0 today. So let's talk a bit about the TNC 4.0. It is a development board. It is super cool and super fast, 600 megahertz, almost 2 megs of flash, 512 tightly coupled around. Like this is a hot rod compared to the Arduino.
Sure.
Yeah, let's find it.
There's some chairs over there. Oh, that's a team set. Okay.
It's many times the power of Arduino Uno, right?
Hundreds of times. Yeah, it's a full 32-bit microcontroller. It's super fun. Now, Arduinos you can find for cheaper off-brand Chinese ones. So why are we using the TNC? Well, under ROS 2, because they wanted more robust and reliable communication between the microcontroller and your computer, they're requiring a 32-bit microcontroller. And there's a bunch of them that are supported out of the box. And this just happens to be one of my favorites, and it's supported. A couple, let me bring up the stats here a little bit more. And so this is what we're using. I've got an example here in a predictive case. As long as I get it back, I'm happy to pass it around. Super cool.
So it's because ROS requires the 32-bit and where else was it?
Yeah, so ROS The micro ROS framework for communicating with microcontrollers only works under ROS 2, and micro ROS requires 32-bit microcontrollers. And there are cheaper ones. It supports the STM32, I believe, and a few, but these are just a joy to work with. They're only $20.
20 bucks. But no other requirements, the cores or anything, that's not what Ross cares about, just the 32-bit. And
it has to be supported natively under micro ROS. So there's a handful that are, and the TC4 and the TC4.1 are two chips that aren't. So the last piece of this puzzle is that if you go to the micro ROS website and go through, hey, I want to use micro ROS, it only supports natively 1 or 2 boards. And then because you're an expert in C++ and microcontroller design, it expects you're able to port that to whatever your platform is. That doesn't describe me very much, like at all. So luckily, the micro ROS folks created an entirely separate repository that they call micro ROS Arduino. And this version of micro ROS supports a handful of boards. And once you ignore all of the non-Arduino stuff that you have to do to get it running, supports proper Arduino C code. So you can pull in servo.h and NeoPixel and all that fun stuff. Let me dig in that a little bit.
what page are you looking at now? This,
So this is the GitHub for the micro ROS Arduino
Okay.
package.
it's called Arduino, but it's showing Teensy there and all these other ones.
Yeah, Arduino referring to the code type, I guess, is less than the board.
Oh,
Right, so writing Arduino code isn't like writing microcontroller code.
oh,
Yeah, Arduino hides a lot of the challenges of setting up servos and LEDs.
so they mean C code kind of.
Arduino C, yeah.
Arduino, yeah.
Yeah, so they support a handful of boards, which is great. And so let me go ahead and switch back over to my Linux VMware. Use the
What's
same
that? What's
trick.
equal, merge is it, or equal,
Control
equal?
Control equals and then control minus.
Yeah, there we go. Control equal.
Yeah, it's a thing to remember too.
He did it.
Brand Huh. Is it making it bigger yet?
It's not- okay.
No, it's Microsoft
There we go.
Visual Studio or Code
Oh.
standard, I guess. It's in the app.
Oh.
Normally, it's just the mouse wheel,
Oh,
or control mouse wheel, like for the edit, for like a browser.
Not too bad.
It's very important for demo for notes.
I think I have
Yeah.
it.
Yeah. And so to skip ahead a little bit, instead of sharing with you how I figured all this stuff out, by searching through 4 or 5 different websites hidden in different sections is everything you need to know to be able to set this up. The bread and butter of platform work is a file called platform any, and it describes the type of board, and it has a rich mechanism for pulling in standard libraries, like libraries that are officially supported through Platform IO that someone's maintaining, as well as pulling in projects over GitHub. So after a few hours of searching, I learned that if you set up some live deps, I can directly pull in the micro ROS Arduino GitHub release with a little hashtag for the version that I want, Foxy. This is all done under ROS 2 Foxy. And I'm also pulling in the Platform IO standard library called FastLed. If you've done any work with NeoPixels, you're familiar with FastLed. NeoPixels are picky in terms of their timing, and this library handles a large array of them, and it gives you simple C functions to be able to program and change them.
Works good too.
The other thing that I've gotten pretty good at is that if I've solved something that was just a real head scratcher, I'll leave a link to the site that helped me figure this out. And for some reason, when you stack all these together, Visual Studio Code, Platform IO, Micro ROS Arduino, there's an internet library that even though you tell it not to pull in, it still tries to pull in. This was about 4 hours of fun. I'd say I was pulling my hair out, but everyone knows that that's a lie. I'm horrible. So we just said, hey, this library that you're super excited to pull in, don't. The build that flag, you can get most of these from the Micro ROS Arduino GitHub page. The part that took me less than an hour to figure out is that you have to hard code the location of the precompiled library that it uses. And so you've got to dig in through PIO and depths and based on the controller you're targeting, NC 4.0, blah, 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 to find that. And then once you do all that, everything else just works. So if anyone's planning on following along or you need to know, just let me know. I'll just pass this over to you. And then once this is in place, you can develop ROS2 code on the Teensy under Platform IO without pulling your hair out.
So at
Yeah.
this point, it's, well, yeah, no one's provided this file or those modifications to it. That's the problem, that you had to, you know, when you knew that it was Teensy compatible because of the Micro ROS, but they didn't give you, there's no Platform IO any. The INI file is the thing that sets up the environment, right?
Sets up, yeah, the entire project.
Or the
And-
project. So when I create a Platform IO, I have an INI file there that I, you know, when I say, you know, import or something, you had to go in and modify it.
Yeah, it required a few extra finishing touches. And this is also my first Platform IO project. So when people write directions, it's like, what do you assume? Do you assume that they're also Platform IO users or an idiot? Well, in this case, they didn't assume that I was an idiot. They were wrong. So it took a little bit of hunting to figure out some of these things. Some of them are optional. That super fast TC 4.0 that I'm using, it defaults to 600 megahertz. You can run it up to at a gigahertz with a little bit of cooling. I don't need to do that. I'm not using it for anything that, but it's just such a cool, powerful chip. So once you have your environment set up, and I said, like I mentioned, if you're planning on doing any of this, just send me a message. I'll save you the heartache, unless you're a Platform IO expert, in which case this is dead simple.
Yeah, because if you were just doing an Arduino Uno project or something, it would, the INI file works out of the box pretty much, right? It's because they haven't added the kind of support that the file that doesn't just download a decent INI file when you select the Teensy. They could fix that, right?
Yeah, and here, let me, I'll show you where the direction side.
You might want to share it on GitHub, you know, or
Yeah.
this is valuable stuff.
Yeah, so they give a template for what the platform INI would look like when you're using this library.
It's, you know, it's for
And they-
Micro ROS, yeah.
Yeah, and they show you, you know, how to pull in the library. They don't mention that the default is a different version of ROS2, so that was a couple of hours. So then using the Platform IO way of pulling in things, you'll put in a hashtag and then the branch that you want to pull. So going back to mine, it's hashtag Foxy. The second one was they provide a helpful template for how to pull in the right precompiled library. So you've got to know that, oh, the first time you compile it pulls in this whole set of live decks. And then you have to know that the Teensy 4.0 supports this specific processor. So you type that in by following the directory structure. And then same thing right here. And the last one was, even though it's not currently used, they say pull the target definition. Well, what is the target definition for Teensy 4.0? I'll give you a hint. It's not Teensy. It's not Teensy 4.0. It's not Teensy underscore 4.0. It's not Teensy 4. It is Arduino underscore Teensy. And in order to figure that out, you actually have to start looking through the header files to see how other defines are used. And they're like, oh, here's a little bit of code that's excluded for the Teensy 4. So it's one of those
Alright.
things like, it's use the force, read the source.
Right.
Um,
But if you
I
were
can
doing
see where
that,
that would drive you nuts.
that's not cool, yeah, I mean, hours of effort, but, is this easier in any other way? Like, if you were using the Arduino IDE, which we just were poo-pooing, or not poo-pooing, but, would it have been any easier? Or is it really the?
It's the exact same,
problem?
yeah. Yeah, this library works just fine under the Arduino IDE, but there's even a few more things you have to do in other
Okay.
INI files to get it to compile correctly.
Worse than.
The big deal is if you want to use his project, you should be able to download his GitHub, hit compile, and everything should trickle down, compile, and work. I mean, I don't know about this pre-compile, that was a weird thing, but that was a neat thing because usually I use one version of the library, use another version of the library, we can never make it work. This takes all the versions, all of the
Neat.
sources, puts them together like a super CMake file.
That's awesome, yeah.
Yeah, so there are advantages.
Oh,
Well,
yeah,
that's fine, just put it, yeah, but you have to share it, or, yeah, like, when you, that'd be great if you, yeah, upload your whatever mini project to, if you're sharing it to GitHub, and then anybody who wants to, work with a teensy can just download your thing and, you know, erase all the stuff involving your specific project and, you know, write their own code, right?
yeah, and it doesn't say a whole lot about me, but this, like, everything that I'm sharing with you now was a full weekend of frustration and caffeine, trying to figure this out. But now that institutionally we have this knowledge, when you go down this path, just remember, oh, Alan's done platform IO, oh, Alan's done Arduino. Take a minute and then just send me a message, open up something on group chat. As a club, we have this knowledge now. There's no reason to reinvent the wheel unless that's your thing. I certainly wouldn't recommend it.
Hey, Alan, can you hear me?
Yeah,
Hey, how are you?
good to see you.
Yeah, I have a question though. Do we have a secretary at the RSSC?
That's me, but I'm trying to get the title changed to social media.
Oh, there you
Yeah, what's up?
If you're discovering all these wonderful shortcuts that would help everybody a whole bunch, it'd be great if we could have somebody document all that.
Yeah, for sure. And one of the things that we started doing at Riverside, now that you've brought it up, is that, so we're doing a ROS2 course, club robot thing. After the meeting, for everyone that's RSVP'd, I'm sending additional notes and stuff for further info. I'll post a bunch of little tidbits to the end of this meeting forum post, just to help anyone else along. But it's a great idea. Great idea. All right, so you've suffered through me. You feel the full weekend of awfulness. Now, how do we actually use micro ROS Arduino? Just like in the Arduino and other things, you start with someone else's example code. And so, just like looking up the blink example to blink the LED, there is an example folder here with an example publisher and an example subscriber. So a publisher is a bit of code that pushes a message out over a topic for someone else to read. And a subscriber is someone that subscribes to a topic and message that receives messages, right? And so in this simple example, my teensy is a subscriber. It has a channel open for how bright to make the LEDs, what color to make the LEDs, and the XY angles for the two servos. So we're going to start here. And I'm not going to drain the source code for this because I only understand about half of it. So I want to share more of the approach that I used. And just like in Arduino land, my first approach is copy and paste and hit compile and make sure that it works, right? And a lot of this code is not idiomatic Arduino code. This is full C++ templates, gross, awful stuff. But there's some things we can pick out. We have define a constant for the LED pin 13. Depending on where you're planning on using this, Platform IO has a default called LED built-in, so that you don't have to know the pin, or just change it to the pin of your device. There are these two RC checks and soft checks. These are, I call them macros. I don't remember what they're called in real C++. is that you can wrap your function in these and it'll do something based on whether the function responds with success or failure. So this RC check macro, whenever you call it, it tries to run the function inside. And if it's successful, hey, you go on, you do something else. But then if it fails, it goes to this error loop function that just flashes the LED really fast. So you can figure that out. And this soft check doesn't do anything with it, but has the same function. So it gives you some control over what you want the code to do when something fails horribly or if something fails minorly. So here's this little error loop function. If you're familiar with Arduino, you can read this and say, okay, it flashes the LED really fast, right? So when something goes wrong, it stops doing everything and just flashes the LED until it resets. We have this little subscription callback. So this is the code that is called when it receives a message. And it looks like it just reads the message, and if the message is 0, it turns off the LED, and not 0, it turns it on. And now we've got our familiar setup. And this is just boilerplate code. The nice part about you doing this under are you gonna let me click? Right. Nope, can't click. Is that when you highlight these, it tells you a little bit more about it, which is great. But again, all this is boilerplate. I don't stress out too much about what these are or what these do. It looks like it creates the node here, and the node has this name, so you can change that based on what you're trying to do. There's some boilerplate, 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 and then there's this loop. So you can see these RC check macros. It's wrapping most of the functions in that. So any of the functions with an RC check wrapper, if they fail, it stops all processing and flashes the LED really fast.
So the LED is flashing really fast, you got a problem.
Yeah, yeah. And so one of the things about working with Arduino controllers is you kind of want to know what they're up to. And in this example code, a couple of things happen. It turns the LED on high, solid, until it's able to open up that channel of communication with your host computer. And so now we can read that. If when we reset it, it goes solid. And if it doesn't connect within 2 seconds, then there's an error. But that solid light means that it's, hey, it's running your code, and we're waiting for that connection with the host. Now, if it can't connect with the host within that timeout period, we have the error loop, a really fast flash that says something went wrong somewhere, something that I saw a lot as I was trying to figure out how all this fits together.
I can see why that drives you crazy.
Now, let me go and switch back over to Arduino, and let me show you how I'm using that light in a similar way. And a lot of the code in here, again, I'm not going to drain all of this. It starts with a copy and paste and figuring out the pattern. If okay, so I have instead of 1 channel, I have 3. How do you set those up? But how to use the LEDs is kind of cool. I have defined this. Let me see where I stuck it. Give me a second to scroll through here. Okay. So I have this little function called heartbeat. And the way that it works is I have this pattern. It should be over 1 second, but it's actually 1024 milliseconds, but no one's counting. That flashes the LED on and off that indicates everything's working the way it's supposed to. Your loop is going through and looping. And I wrote my own macro that I can call from there that based on the number of milliseconds and some clever math, it turns it on and off. And then I just call that macro from my loop. My loop actually does a couple of things. I check every 10 milliseconds, I update that heartbeat, and then I do this boilerplate code, which calls in all of the ROS goodness. Now, here's what's cool about this, and it's spread across several different functions, but this LED communicates the status of the microcontroller. Just like in the boilerplate code from the website during setup, I turn the LED on and I wait 2 seconds. And in that 2 seconds, it has to be able to start communication with the host controller. So it's solid and then something else happens. If it's not able to communicate, it'll flash super fast. Okay, so something's happened. It didn't communicate. I didn't run the ROS agent. You know, something's wrong. Look further into it. And then once it connects and things are cooking the way they're supposed to, I call this heartbeat macro. And so now when everything's up and going, I can look at the chip. I can see this heartbeat, which is running right here. Let me see if I can pull up a quick YouTube clip. Now I'll do it during the break. So this tells me that my code is running, the loop is going, and if anything bad happens, if I send a malformed message, then it starts blinking flash. And this is incredibly powerful. This, instead of guessing, and it could still be doing something weird, but once you see the heartbeat, you know that your loop is looping and it's doing something, which is pretty cool. The last little bit of weirdness, if you find yourself building these more complex bits of firmware with ROS2, microcontrollers are resource constrained devices. So under Python and ROS and computers, you just declare stuff and it figures it out. No big deal. Not a lot of memory on microcontrollers. So there's a couple of things that you have to do. And this was another 4 hours of my life. But now that I know it as a club, we all know it, right? So you can always ask. I have 4 subscribers. One for color, one for brightness, one for blink that I don't use, and one for the angles. When you're writing the code, there's this little number here that says, hey, how many cubby holes for subscribers do I need to set up? I didn't know this. It was 1 by default. I didn't mouse over to read it like I should have. So after about 4 hours, I realized, oh, I've got 4 subscribers. I need to pre-allocate 4 buffers for that. The second piece is that when you're going through the examples, when you're setting up the messages, you have to pre-allocate how much space you're going to have for them. Now, for simple messages, if you're just passing an int or a uint8 or an int16 or a uint32 or a float, you don't need to. It knows how big it is. But when you're passing a more complex message, like the angles are a multi-array of 2. You have to pre-allocate that using some really C++-y way of doing that.
C.
And
No.
there's no examples on his GitHub that show that. And every once in a while, someone will come back and say, hey, why am I getting this error using this complex type? And he will always point them back to here. This is what I love about the kids handling new ROS nowadays, is somewhere in here for you C99 experts, it describes that you have to pre-allocate the buffers for complex memory types. Now, I barely understand what that is. And this is the first site that he points us down. I keep meaning to submit a pull request for an example with a complex type just to get people pointed the right direction, because the people using micro ROS Arduino aren't necessarily C++ experts. They're Arduino writers. And this is a very not Arduino way to handle stuff. But so once you have all of this in and you've got it compiled and you have it assembled and pushed out to the teensy, here's how all that fits together. Go ahead and move some stuff out of the way as we wrap up.
So like Thomas said, you could be the champion and document this thing for the next.
Yeah.
Want to use this.
It's one of those things, giving back. Okay, so I've earned this knowledge.
Right,
I Google search the S out of it, and now I know how to do complex types. I want to submit as it's called a pull request, right? It's, hey, I have an idea for your code. Maybe you can add this to your GitHub that has a complex example, just so other people are a little bit less frustrated. I just need to get around to it.
Oh, you mean to the micro Ross
Yeah.
people? Or
Yeah.
To their GitHub, under examples, right?
Yeah, because I know he gets asked constantly, and I don't know why it hasn't been added. He's probably, on the other side is like, I'm a C++ expert. Why wouldn't you know this?
Well, there might be just too many things to.
Yeah. So it
it's
never hurts
much.
to submit it. Yeah, he doesn't have to accept it.
Oh, they'll probably, yeah, they may.
Is that Ross running right now there?
Uh-huh, exactly.
Oh, that's cool.
All right, so once all that's in place, so here's the behind the scenes payoff. You've seen it work. I'll keep this up during the break. When everything's running, you run this what's called a micro ROS agent. So micro ROS Arduino takes your messages and it serializes them and pushes them over the serial cable. It's 1 megabit virtual serial IO. And then you have to have something on the other side to translate that. That's micro ROS agent. It's a little program that grabs the USB serial port and then translates back and forth to communicate the messages.
So that's how you go back and forth between Ross and the, okay.
Yep, and if you carefully read every line in the GitHub, you will know that when you run this locally, let me see if the shortcut works on that too. Nope. Okay. Let me try the other one. Oh, that's big. That's a big one. All right.
This anything? That's like the key, it's the key.
Da-da-da-da.
I learned something new today. Thanks, Jim. Is that using the ROS2 way of calling programs, ROS2 space run, the package is micro ROS agent, the application is micro ROS agent. We're initializing a serial connecting to the serial port T2ITM0 and verbosity. Let me turn that down to a 3. That's how verbose you want the on-screen messages. Anywhere from connected to here's every byte that I've seen and why you want to look at it. I'll turn it down to a V3. All right, so now that's running. That's one node. Getting back to the getting back to that diagram, we used RQT graph. All right, let me go ahead and refit that. So that is the connects the TNC back into the ROS graph, the connection of messages and nodes. And so that facilitates this piece right here. Let's go back to our prompt. And because I turned it off and back on, I'm going to reset the TNC. And if you're close enough to see, you'll see the light turn solid for a second. And then once it communicates, it starts the heartbeat. So I know everything's working the way it's supposed to. Super cool. Let's go over to another window.
So what is that little board that the light's attached to?
Oh, this is the TNC 4.0.
Okay. Oh, like that one you were showing. Okay.
Uh-huh.
Okay.
And that joystick node, that program that's built into the ROS toolbox that automatically connects to a joystick and publishes joystick messages, will run it the same way. ROS2 run the joy package, the joy node, the program.
Now, is that joystick hooked into your Raspberry Pi?
It is hooked into the laptop.
Oh, laptop. Okay.
Yep.
Never mind.
Yeah, and then through the magic of ROS, they're able to communicate. Let me just take a quick look and make sure that the removable. Okay, good. All right, so for the third window, and this is just me doing it manually. There's a whole framework in ROS2 for setting up a script that launch all of these automatically called a launch file. I'm just doing it by hand to show you how everything fits together. Now, in the third one, in 30 minutes, I wrote a quick program that looks at the ROS2 topic echo joy. Let's say I want to see these messages that are being passed along. And let's embiggen that a little bit.
Oh, those are raw positions of the joystick there.
Okay, that was a little bit too big.
Oh,
There we go. A little bit hard to see. So it's passing about 20 messages a second. There's a standard message format. And as I move press the buttons and do the things, all you have to do is read that message and you get the position of all the joysticks and the buttons. You get all this for free. Moving back over to the joystick program that I wrote that takes those messages. And I'll just show on screen the position of the brightness controller. And so that's how you get to the end. So the inode is running on the Teensy. That joystick controller is that bit of Python code I wrote that ties them together. And the joy node is what you get for free out of ROS2 that takes the joystick and it publishes messages over joy. And when you get that all together, you get an eyeball that blinks. Right. So now that this is all done, these two eyeballs go in the head. Next month or the month after, I'll give a follow-on talk on the neck mechanism that I'm working on. And so all these are going towards modifying a 1980s toy to be the robot I always wanted it to be as a kid.
Thank you.
All right.
That's cool. I like it.
Yeah.
Very nice presentation.
That's a lot of work.
Yeah.
To make a giant move.
All of that?
Yeah. Several weekends of frustration.
But
All
you
right,
moved an eye and
so
you
we'll-
blinked it. and you
We'll have
blinked
a
it.
little 5-minute break while
Okay.
Tim gets set up. Yeah, thank you, Alan. That was excellent.
All that to
presentation.
blink an LED and move.
All
on.
of us are like an LED. I don't know why people say ROS2 is so complicated.
Well, and I don't know, some of that's code, yeah, into roster, but it looks like it's,
My issue,
oil.
my issue with
Yeah, Lex.
stuff has always been the directories they set up. Because invariably, they end up with about 10 stacks of subdirectories.
Yeah,
When you try to decipher the code when you have an issue with something or something gets lost, trying to find it in the directory structure can be very challenging in large projects now.
Yeah, for sure. And that's
Simple. And this
Yeah,
is-
that's one of the coolest things about the Visual Studio Code is that you can surf the source directories. As long as you pulled it in, right, and there's source code available, you can actually surf through those directories without knowing explicitly where they are. The ID takes care of the locations for you. That's super powerful once you get it more into the use the force, read the source kind
as
of
long as it
projects.
works.
As long as it works, yeah.
But invariably, I've had crashes with Microsoft stuff. I avoid it. And your mileage may vary.
Your mileage may vary for sure.
yes, you look nice, Thomas. How you been doing,
Thomas,
Mike?
some cool stuff
Okay?
over there.
If you just.
Can't wait for your show and tell.
Yeah, so far, Thomas is first and only show and tell. If you guys have a show and tell, either put it on the chat or let me know so I can add you to the list.
Yeah, I always have show and tells. I got too many projects.
You help getting back in here?
We'll do that on the business meeting.
Yeah.
Actually, do I, to share my screen, what do I?
You can
Do I
log
plug
in.
into your, or
So
just
you
log?
can log into the Zoom
Yeah.
yourself,
Oh,
but
okay.
don't use the audio. We'll use the audio from here.
So mute the mic and turn off the
Maybe we
speaker.
should
Just
show
go
and
and
tell.
activate the audio from the
And
beginning.
not have a lunch.
Yeah, don't join audio.
Yeah.
The Outpost convenience store is open.
I was
Do it
thinking
that
I
way?
have to plug, I forgot.
Or, okay, the
Thought I'd
sign
have to
says
plug
that
into
they're
your
open
projector like the old days. So,
Should probably call him. But I don't know if there's only one show and tell.
Oh, I see what you mean.
Yeah, not one, just go through all the way, show and tell, and then
No, yeah,
people
you're
want to go to lunch or read.
Okay.
I'm thinking. Before, because we have so many show and tells, we have to
Yeah.
wait. And
Yeah, that's a really good point.
what was it?
Oh, if we only have one show and tell, let's do it after the next talk and then we'll break the lunch.
Oh,
Is anyone else,
I'm doing show and tell.
Okay.
Oh, okay, so let me add you to the list.
Yeah, I'm sorry, I forgot to.
Yeah, Jim always has show and tells, right? Jim, gotta show up that orange. Jim? You hear me? Yeah.
That's
I'm
right,
too-
John.
I can't control that.
I can go just whatever, I mean, initially just 15 minutes, 10 to 15, yeah. I'll stop and then if there's more time, we'll.
Sure, I mean, we don't have that many show and tell, so,
Not tonight?
Yeah, I'm only
so-
about 5 or 10 minutes at the max. Jim, you can follow me and it'll be just quick and then you can use up the remaining time.
I'm on.
yeah, perfect. I see you.
There you go.
So,
Brian, Sam, you?
so, yeah, I just talked to.
Working 2 jobs now, so.
Oh, better
You can talk from there since the camera focuses on wherever you're at. and It'll highlight,
Doing some work.
So you've got it trained on me now?
yeah.
Garner Holt.
I know you said the name before, yeah.
Let's see.
Need to design some electronics. Other company called Proper Solar, which I work for, there are part of the company that works for.
All right, well, I'm going to talk about, today I decided, or I guess I just decided randomly to, because it's the latest thing I've been working on is the new audio microphone improvements to Big Orange. And I recently got this speaker array, microphone array called the ReSpeaker V2.0 from the Seed. That's with 3E's Studio. And so just as a reminder, this diagram here shows what Big Orange is. There's quite a lot to it, or a lot of pieces. And but yeah, I've replaced the speaker microphone. I had a Bluetooth speaker microphone, and that one I'm just using as an amplified speaker now. It was an amplified Bluetooth speaker and microphone. But the so this is just a quick diagram. But what I'll show you next is the speaker microphone. It has an output for a speaker, and so I plug that into my amplifier. So so what happened? I guess I'll start with the story. Well, actually, I decided I'm going to show you the final result, so you can see the benefit of all this first, and then we go into the detail. And let's see, go to where is my, oh, it should be YouTube. So, yeah, in these videos, so what happened, well, okay, here's the videos I want to show you. Oh, do I have to? Probably have to share properly, right? Video clip and all that.
Orange, go backward at 50 degrees 2 meters.
Okay.
Let me start over here. So this is what it looks like on the bot. It's plugged into USB into
Orange,
the Windows
where are you?
system. It has this nice
I'm at the person location.
NeoPixel light ring, which is controllable via a Python library.
Orange, go backward at 50 degrees 2 meters.
Okay. It also knows the direction of your voice is coming from. You can see sort of as you talk, it lights up in this one bright light. that indicates the direction of the audio. And this is all in the hardware. It's a very sophisticated audio processing chip and board.
Orange, what time is it?
And here's an example of the far field.
It is Thursday, March
This is
10th at
16 feet
9:44
away.
p.m. It's evening.
And it could hear me clearly. You just have to speak towards it, directly in that direction. So, but it's pretty amazing piece of equipment. And
Orange.
let's see that's the next one. Oh, this is the come here behavior. Now, the other one I want to show you is the, okay, now I can start the story. The story of what happened was I went to the aquarium. We were invited to show our robots off at the Aquarium of the Pacific in Long Beach. And Orange was invited to deliver drinks to some people. And so I went there early and I tested everything in this big cabinet space and was, reasonably confident things would work. And then when everybody piled in and all the people were there, there was this low level of noise and I could not speak to the robot. It could not hear me at all. And I should have just went to manual control and delivered the drinks manually, but I kept trying to fix it. And that wasn't going to happen because that noise level was enough that the way the code was written, it would not adjust for that. It would not ignore. It thought there was just constant talk. So it keeps recording and recording till the buffer fills up and it never, and then it's all just, noise. It doesn't, and you can't even shout at it, or you could try, but. So I looked into this problem and the code I'm using is this library called Speech Recognizer. And it happened to have an adjustment for ambient noise, which I wasn't really using. I was just setting to a constant. So let me show you this video, which is my experiment.
Orange, how are you?
After working with this, what they call energy threshold. A lot of microphones do this, I guess, in the analog world, as or even your web camera microphone, when there's background noise or a certain level, it will squelch that based on when you're not talking. It kind of auto adjusts. And so this is a similar type of thing, except it's all controllable by software. So what happens in this code, this is a speech recognizer. Actually, I can, well, I'll show you that in a second, but the speech recognizer is a Python library, and it's the front end to multiple possible back-end speech recognition systems that you can put in, that you can select, like Google Cloud or like the Sphinx, Pocket Sphinx, and now what I'm using is called Boss. And I'll show you that in a minute. So what I went in and did is I tried to utilize this energy threshold. And now with there was a feature called dynamic thresholding, and that in the software, and you could just enable it. And that dynamic thresholding would try to adjust based on when you were not talking. And so it could go, the problem with there was a flaw in that code. This was in the library. It could only go lower in this dynamic threshold is a number, say, for the amplitude of sound in that it's hearing, right? So it's saying the concept is if the amplitude of the sound in the room when no one's talking is like 100, then don't try to interpret speech anything 100 or below, because that's all noise. So if the level goes up to 200, then, or something higher, you go, oh, maybe that's someone starting to speak. So that's the concept of it. Now, their dynamic adjuster in there, it would have while it was listening for speech, it would have a loop, and it would say, is the noise level, is no one talking? And the way it could think, but the way it decided that no one was talking is the noise level below or equal to the current threshold that's set? And if it is, then it would keep looping and then check the energy threshold, take a new sample and say, oh, okay, it's only, so suppose it was 100, then it would sample, the last one was 100, then it was, no one's talking, and it samples it and it says, oh, now it's 50. Okay, I'm gonna set it to 50 and keep listening. But the flaw in the code was that if the value went higher, it always assumed that was someone speaking. So what if the noise in the room grew and no one was speaking? Then say it was set at 50 and the noise goes up to 100, it immediately breaks out of that sampling loop and then says, oh, someone's talking, let's record him. And so this is a problem because if the noise grows, that energy threshold never goes up. And so that was the flaw with that dynamic mode. Now, I was able to improve that with the speaker array, which has a bit telling you speech is being heard, and they do that through the hardware. So I've improved that, and that's the latest version. And now in this video, you'll see what I was doing to manually, I turned off the dynamic, and I was manually taking a sample between commands. Essentially, I knew if someone issued a command that they had finished it, they're not going to be talking immediately after that command. So that's when I slipped in this check for the ambient level. So watch this.
Orange, how are you?
So here you'll see that the threshold
I'm
is
feeling
50.
happy.
And what I was doing here is I have
Orange, how are you?
a video running in the background, which is crowd noise off of YouTube, and I was ramping up the volume on that.
I'm
slowly.
feeling happy.
And now I had to like go through a link just to get used
Orange,
to
how are
this,
you?
because the microphones were canceling it out and trying to record this. So it's just
I'm
like,
feeling happy.
you know, this crazy thing that you can't.
Orange, how are you?
You can't. And if you put the threshold on,
I'm feeling happy.
it's for the good stuff, right?
Orange, how are you?
I had to record this crowd noise with another microphone for the gum.
I'm feeling happy.
But my voice was coming from a different
Orange, follow me.
microphone. Okay, that's
Okay.
so what you saw there was it got up to 200 and it kept ramping up properly, which is what you want it to do. And that's not the latest code. That was I guess I should, if there's any questions as I'm going through this, because
I'm feeling happy.
oh, you can't read the, you were saying you can't read the text.
Yeah, that's the one.
Orange,
downside of
follow
that.
me.
Okay. I will follow.
Oh, it should, you know, I wish it did that automatically or something.
Yeah.
Or do you just type new share? And then turn off the,
Yeah, you can stop and then restart without.
what does new share mean anyway? Is that,
I'm sure.
in other words, you don't have to stop and start
Oh,
again.
okay.
Is that what that means?
Oh, maybe you can share a different screen or whatever.
Is this now readable?
Orange, how are you?
I'm feeling happy.
So can
Somewhat
you,
readable.
oh, now it went blurry again.
Yeah.
Why?
Orange, how are you?
So when you share, you didn't optimize for video.
Yeah, but I turned this off. You're supposed to turn it off to see text, right?
On the bottom, when you say share screen, there's a little arrow, if you click on it, it gives you options to optimize the video. On the bottom where it's the green share screen option.
Yeah, but this, if you turn this on, that makes text blurry. Or that was the first try was with that, and the second try was with it off. So neither one is working.
I'm feeling happy.
That's if you
Yeah, go to-
generally what I've learned is if you turn on optimize, it won't do text.
Yeah, it does blur the text.
And if you turn off optimize,
I
you
see.
have a chance to see
Oh,
text.
Okay.
Like, yeah. But maybe I have to like
Yeah.
quit something? I don't know. Or maybe
Or what resolution are you playing the YouTube video?
I'm just on a web browser
I
here.
know, the little cogwheel, see
Oh, what resolution?
what resolution you're doing? Oh,
Well,
yeah,
the resolution of
yeah, you were at 360.
the resolution of that video isn't very high. This one here, because it's just a screenshot. Oh, maybe that was.
How are
Yeah. Now it's second clear. Perfect, good job.
I'm feeling happy.
Change, thank you. Yeah. Okay, I'll do this again. So you see now it's 50. Now it's gone up to 60. And what it's doing is it's sampling the ambient noise between commands. Because it assumes
I'm feeling happy.
no one's talking then. That's just an assumption.
Orange, how are you?
And the
I'm
sound
feeling
noise
happy.
is actually louder than what we're hearing here. In real life.
how are you?
I'm feeling happy.
So it's understanding me.
how are you?
Now it's my voice that get louder too. And you have to talk over the.
I'm feeling happy.
And my voice has to go above that 292 or 300 in order for the robot to hear it.
Hey, Jim, how loud do you think the noise was at the aquarium?
The aquarium, wasn't any higher than that.
Okay.
So it probably would work. There's another problem with people talking. If multiple people are talking and it's not just if it's just, then the robot will try to process that. And so like, you really can't have multiple people talking that's within range of it, of the same amplitude, or it will not, it'll just get all the words mixed, of course, because it doesn't know whose voice is the commander, So it will mix them all. So like if I try to command it here, when people are talking amongst themselves and I try to give it a command, it's going to get words from all of what it's hearing. And so I put the NeoPixel, you'll see that, or actually I just showed you. After this video, I added you'll notice like when you talk here, the NeoPixel
Orange,
kind of
where are
brights
you?
up, and then it does that.
I'm at the
So-
person location.
I added to the NeoPixel. The NeoPixel has a routine, has a little library, and it has different modes, very similar to your Alexa Echo device. Or yeah, I guess Alexa Echo is famous for having the ring of lights. So here you have, it has this thing is called trace at the beginning here, where it lights
Orange,
up.
where
when
are
it
you?
hears That red light will indicate speaking, when you're speaking. And then it goes into thinking. It has a thinking.
I'm at the person location.
And this is just like, these are presets for you to use. Like you can call the think, and then you can call the speak mode, which is a different one, and then you can call it. So you can control the NeoPixel through this interface. And so what I've done is now, if it hears something, it will go into that think mode or think like that. And then the person knows I can't talk now. The robot's not going to hear me while it's thinking, right? That's kind of, I mean, the Amazon people and other companies, they've discovered this long ago. But I'm glad to have a way to put it on my robot. So So in a noisy environment, if it hears something and it thinks, oh, I might have heard something, it'll go into that thinking light, and then you know that you're not gonna give it a command at that point.
Yeah.
You have to wait until.
What's
Yeah.
the product? Sorry, what's the product called? The ring with the little.
So this is called the re-speaker. And okay, now that I've given you that background,
The what speaker?
it's called re-speaker, R-E speaker, and here it is. Here it is.
Sounds interesting.
The what is that window?
Yeah, it's got its own board and everything.
Yeah. So this is a $64 board. How do I get rid of this?
It's a microwave.
Participants. Search. Just do that too.
You're right, it is kind of like the Alexa.
So,
thing.
yeah, so this is the board. People were recommending this on the homebrew robotics, I think is where I first saw it. A guy named Scott Horton, who's kind of a hero of mine. He in Silicon Valley, his Elsa bot was a fellow entry into the open CVAI competition, and he utilized this board as well. And I actually even have a case for it, that's the official case. I 3D printed one, but I'm not using it. I'm not sure if it's affecting the audio, the microphone. So yeah, there's a few things about this. You saw my demonstration of I was just trying to get it to work as far away as I could. And to me, it was like 16 feet, and they say 5 meters, which is about 16 feet. So, so I guess I verified that this works. And same with Alexa. Alexa can hear you. I don't know if everybody's had one, and you say something quietly, and then she hears you like 15 feet away, and you're like, darn it. And so now Orange can hear you. In fact, he heard someone here. Like, what? I don't know if they're here, but somebody heard what, and Orange responds to a few commands without his name. So if I go to here, probably.
You turned it off the thing.
No, I didn't bother actually.
Oh,
What's your name? What's your name?
He's mad, he left him alone.
Here.
Yeah, he did it.
What time is, Orange, what time is it?
Sorry, I don't know about that.
that's
Orange,
Alexa.
what time is it? Orange, what time is it? Right, it's a little far, but anyway, you got his name though. So, there's also echoey in there. Oh, that's the other thing. This is a side note, but I recently, and it's a good thing I did this week. Recently, I added a new speech recognition choice backend, which is called VOS, and I have that. Maybe I'll bring that up after this, but that one is I have the page here. That is an offline speech recognition system, and it was fairly easy to put in. It is supported by this speech recognition Python library, and it's brand new. So what is it? Where's that there? And there it's called here. It is. I'll talk about this in a little bit, but it's based on Caldi. If you're familiar, you've heard of Caldi. But I dropped this in because I was really sick. Another problem at the aquarium and other places is trying to get Google Cloud Speech to work, because you've got a roving robot, you've got to hook up the Wi-Fi. The Wi-Fi kind of is a little dicey in certain locations. Maybe I don't have big enough antennas. It's a moving robot. It's got lots of stuff going on there. So that is just a problem. And the latency, even if it is working, the latency of sending to Google and back, because sometimes you get a long recording because there's a little noise. And so this is trying to send up a lot of information. And I say, I want, local speech. And so a while ago, I implemented, a long time ago, I already made this kind of decision, and I implemented the, actually from Gary's code, I think it was the using the Windows SAPI speech. And so that had been my go-to standard. And that one was it's a very old technology, and it only could recognize me. My wife couldn't talk to it. So finally, I'm like, okay, that is a dead. That is not a viable local speech system. The Google speech I'm really disliking because of these other problems with latency and the requirement of network connectivity. Here, I just brought the robot. It's not even on the internet. I couldn't get my station to work, and I don't want to go through all the hassle to connect it to this network. It's recognizing because it's local. So that's my push for local speech recognition is the way to go if you want to have a demo with that actually will come off rather nicely. And okay, so the finishing on this. So the whoops, that's kind of weird. What happened there? So yeah, there's the different features. The far field voice. You've got beamforming, which is how it's a digital signal processing technique that will focus in on a particular direction once it starts hearing, and it will because it's got a microphone array. It can tell. It's bringing in the audio from the multiple microphones, and it can detect where the highest amplitude is, the direction, DOA, direction of audio, and then the beamforming allows it to. Then it goes, okay, I'm going to focus even narrower on just that that signal and use the mics that are off. The other mics, it's going to use those to sort of ignore stuff coming from the other directions by subtracting it out, basically. So I don't know how that exactly works, but that's what beamforming is. And then you've got noise suppression, and that also helps get rid of background noise. And then you've got this other thing, de-reverberation. I'm not sure. I think that's the whole echo or the kind of reverb in the room, how the room acoustics might be different like it is in that hall. And then you've got acoustic echo cancellation, which is a standard feature of all devices for conference calling, where it won't kind of double back your voice as you're speaking into it. It will cancel out, or if there's like music playing, music coming out of its speaker and you're talking into its microphone, it can subtract out that music, and this device does that. So acoustic, these are standard features of commercial products. And here, this one is a demo of
Seed Studio Mac Test 1, 2, 3, 4. Seed Studio Mac Test 1, 2, 3, 4.
So here's a quick demo. There's music playing. Now, here's the music. And here's the final channel 0.
Seed Studio Mac Test 1, 2, 3, 4. Seed Studio Mac Test.
That's the acoustic echo cancellation.
So it has its own speaker built, like the cancel it?
It has an output. So you has an output right here, 3.5 millimeter jack. I plugged it into my that speaker Bluetooth thing that I've been using with its own battery, and it seems to work great. And it's even louder than it was at maximum volume before, because I guess when you when you plug in an external device as
Right.
opposed to over Bluetooth, you get more volume.
Yeah.
I
Direct
guess
connection.
because there's some current in that, in the input line.
Yeah, that's pretty cool.
I think even with my inexpensive speaker there, that might be loud enough for most applications.
Yeah.
It uses the special chip, this XDF 3000, 4 microphones, and then it's got those speech algorithms. They're wonderful, NeoPixels, which just are beautiful, and other information. 5 volt. It's pretty small, and it's got great sensitivity there.
This is the only company that sells it, the Seed?
Yeah, Seed makes it. Now, there's other, I won't say this is the only one. There are many of these products on the market. Just look for speaker or microphone arrays.
But this one has been proven.
Yeah, this one, and there's other ones that other people are using. In fact, don't you have one? You have a different brand, right?
I don't know if it's brand or not. It's been a while, but it's just almost identical features.
Here's-
The LEDs, the directional output, all that stuff. And even the XMOS, it uses the XMOS internally, so I'm wondering if it's the same board or not, I'm not sure.
Oh, it might be the same board, but it's a different package. Yours is I remember yours is a slightly, I looked yours up. But anyway, this one was recommended by people. And what's cool about it as well is the Seed company, they're pretty good at providing information, technical information. So this is the wiki of Seed. The other part was the sales page. The wiki will give you more details, all the details you need to get it working, including sample code and diagrams of, well, the hardware, all those specifications. And see, here you go. Voice interacting robot is one of the suggested applications. So that's me, that's us. And yeah, here's it starting to go through sample code. Now, another thing I've used out of this, which I'll show you in a minute, is the, well, I think I mentioned it already, the speech recognition, or they have 2 things, the VAD, voice active bit, and they have a speech is being heard bit. Here's, by the way, here's the LED, the pixel ring. So you have all these different things you can do, all these different modes that are already there. Sorry, I'm just making it bigger here. This is how you get at all these different variables. They call it tuning. One of the main ones is, this is what I'm also using, direction of angle. So you'll see that in, I'll play that video now, actually, after this, the Orange Come Here video. So it's using a USB through Python and sending commands via USB connection. These are the pixel rings. So you have different modes. You can play with these, but they're all different things that are very applicable, spinning and thinking and speaking. And then you can do it. You could just do manual control of the colors yourself. You can even set the palette, and I've set my palette to orange naturally. Just did that the other day. This is that VAD thing, which is, that center. The center red LED is directly connected to the voice, voice detection VAD. And so that, but I found that this voice VAD is not as good as the other bit, which is called speech. And they don't tell you how that's implemented internally. But this is how the code is for just a sample code for how you would use the pixel ring. And it's pretty easy. Let's see, you have to, I'm not sure where they didn't put in the code. There's code that you have to connect to it. And then, you have to, I'm sorry, they're importing it, that's why. So you connect to it, connects, and then you can do these different commands. Here it is. Yeah, this is the creation. It uses a class called Pixel Ring. When you create this class, it connects to the, or actually here's the connection, USB core find. So it connects to a particular device and a product ID, and then through the USB core. I'm really starting to love Python. I mean, how long would it have taken me to understand how C++ to do USB stuff? And here, you in 5 minutes, looking at code, sample code, you're connected to a device and doing these complicated reads, control functions, as long as someone provides that for you. So here's the really important one I wanted, direction of arrival for the robot to do intelligent movements. So when you say, I want to say, Orange, come here, I want him to turn directly to where the sound is coming from and come to me, right? Now, my first version of that code was, and that was working, and I videotaped it and put it up. I would say, Orange, come here, and I just tell Orange, turn in a random right or left randomly, and keep turning until you see somebody with the camera. Okay, that's works. You might have to go a little slower though when you're turning, because if you go too fast, even an AI camera can't keep up with that bounding box detection of the video going by. So I'd rather have the robot given, this is an optimization, although it's a cool optimization with audio. So you say, Orange, come here. Orange computes the angle to turn to. He tells his system, turn, 110 degrees or whatever. It usually is going to be less than 180. It knows which direction. Is he on my right or my left? He turns at full speed, essentially, or not full, but a faster speed to a known angle. And then he starts looking. Or then he starts looking for the person. So as long as that microphone array is working, or the direction is correct, he's going to get to you faster. Actually, I can show you. And so here you can see how they use it. You get angles.
So you make it move toward the angle of the sound.
Yeah, so the angle to the sound. So now,
then look around.
Yeah, then start looking around. So let me show you actually this is part of the story. I can show you the first come here behavior, which was, I think, this one.
Orange, come here.
Okay.
So this is with no speaker. You notice there's no device there yet. So now he just picks a random thing, turns around at that speed. Note that the speed he's coming or turning, and responsiveness. So now once the camera sees you, you're fine, or it's fine. Okay, and then I do it again.
Orange, come here.
Okay.
So now he might turn the wrong way and go more than 180 degrees. Like, see, it's because it's random. He has no idea where you are. Because he can't see you. And he has to go slow. And this is just the beginning. The first feature that I would use is, the ability to know where the sound is coming from and turn.
Thank you, Orange.
Obviously, there's many other features, things you could do. And
Orange,
so now,
how are you?
let's go to this one. Is this it?
Orange, come here.
Now you can see the microphone arrays there.
Okay.
Now, I don't know if you can see that, but look for a bright light coming on the wheel in my direction.
Orange, come here.
That one right there. There was a bright cyan. You'll see it in person here, but I have it.
So basically that detected the direction.
Yeah, that detected the direction. Now, see how fast that turn was?
Okay,
That's the difference between something like, okay, and something, yeah, that's actually maybe useful.
So now you're standing right there, so it's come up to you, it's fine.
Yeah, it stops. So here we go again.
Orange, come here.
But it's like that light right there, that
Okay.
one was lit up bright cyan.
Uh-huh.
And now see, he turns the right way. Now it doesn't always work perfectly because
Okay.
there's only so many sensors, directional sensors on here, or not direct, it's only so much angle precision they have. And if he's a little off, then it's worse, because then he may turn the wrong way, because then he has to go randomly, and they might turn and go 300 degrees.
Orange, where are you?
Okay, anyway, so that's that. But of course, I only recorded it, I recorded a couple of times, and a few times, one of them it failed to come, to get the right angle, but.
So why didn't you put that sensor on top of the head?
Well, I'm working out the placement of this hardware, and it's not done yet. I mean, this is a work in progress as far as the hardware and whether it should go here or, I'll take advice from people, honestly, because maybe I should put it somewhere. I can't get in the way of the camera up here.
And you can build something that's above it a little bit.
Yeah, there might be, I haven't figured that out yet. Maybe some people could help me with figuring out where to put that thing.
I like how it LED shows, okay, talking from that direction, and then where the one in the middle is, it's detecting this.
On top of his
Detecting your
head.
voice, whatever. So it's sort of cool.
Yeah, you mean that's the DOA, direction of audio.
And did you have to orient this device? Because it has to know what degree forward is. When you say 50 degrees to the left, it's,
Yeah, so I mean,
there must be a mark on that pixel on the respeaker that is aligned with what forward is on your robot.
yeah, well, that's why notice it's the way this is oriented is that the cable's in the back right there, and it's angled so that, or it's positioned so that the very front of this board is directly the front of orange. And I can actually show you the code for that. So essentially this thing becomes I'm on your right or I'm on your left. It's because it's relative to orange. Wherever he's turned, particular degrees, in this case, I think 90 degrees on the board is where orange is pointing at where orange's front is. Yeah, that's how it
So
works.
you had to compensate, you had to
Yeah.
calibrate that basically.
Where is
Yeah.
microphone one on that right now?
Well, the microphones are these little, it's hard to see, but these four little chips or
Oh,
little
so
tiny
is
microphones.
microphone one that, where is
So the
it?
microphones are
Yeah,
off
no.
to the sides here.
Yeah, I understand that, but where's the microphone number one?
Oh, I don't know which one is one,
Okay.
yeah,
Okay.
well, it doesn't really, yeah, I'm not sure which is the actual number one, but they're all, there's nothing that significant about number one.
Okay.
Now I can also, it's actually that this is a good segue into the code a little bit, because, and this should be big enough now. Is it now? Is it
I was gonna
readable?
use this one on my animatronic figure thing, I would have it, they turn the head to where that sound's coming from, so it's looking at you.
Yeah, that you can do that with this. Okay, so here, this is I'll show you some code now. It's always good to have a little code.
Now, this is all Python?
Yeah, so I wrote this microphone array, okay?
Mhm.
And now it does that incantation to connect to the through USB. It gets to this other library tuning is the way you get to the variables of that are published, essentially published or set by this microphone array. And there's a whole slew of them. There's lots of things that you can poke into it to change its parameters, all sorts of settings. I'm not getting into that, but one of the most important ones, or the ones I needed so far, are this get DOA, the direction of audio. And so to get that, you just access the variable through this tuning library. And then there's this other one, which I told you there's one called there's a voice one. There's also one called speech. I did some experiments, and the speech one is better at detecting when someone's talking. And what's interesting about that is a violin playing in a concerto or whatever also triggered the speech flag. But other than that, so maybe it's at the same frequency profile as speech, I don't know. So it's not perfect, but the is voice flags, they have two flags. One is called the VAD, which is, and it's accessed via is voice, and another one called is speech. Now, these aren't documented that well. The VAD is given an example of, but I found that the is speech one was much closer to correctly showing when I was speaking, except for the violin thing, which is kind of a weird case anyway. And so here's your little geometry to convert the direction of audio to the yaw delta, which is, yaw delta basically means on your right, on your left. So yaw delta of 90 means it's on your left, and yaw negative 90, it's on your right, that kind of thing. And so it's a simple little equation here to convert to the yaw delta, and then that number is used, for instance, in rotate to direction of angle, it gets the yaw delta, and then it turns yaw delta. But at first, this a little bit perplexed me. I'm like trying to figure it out late at night, and then eventually I figured it out and was like, it's simpler than I thought. As long as you orient that thing in one place, that gives you this constant offset. At that point, then it's just a delta. Turn to the left or right, or further than that, all the way to the right behind you, etc. So that's that code there. Pretty easy to use. And what was I going to show? Back to I guess the whole new share thing is like if you just want to switch windows, right? That's kind of what you use this for, the new share. And then I'm still learning Zoom after all this time. It's where's the YouTube gone? Right, okay, so you saw the direction of angle. I guess we did all the YouTube. You've seen the direction of angle, or and the come here behavior, and the NeoPixel ring. All right, and let's see. And you've seen the let's just go ahead and close some of these. All right, I'll leave it up. What else is it gonna do? A little bit more. Okay, so that's the whole, that's the new microphone array. Any questions about the microphone array before I talk?
Yeah, I have a question about how you trigger the speech. So you talk about this level, and you talk about the is speech. Do you wait for is speech to go positive and then start recording? Or how does that grabbing the audio to?
Oh, I was talking a little bit about that, and I was prepared to show. So the library there's a library that I'm using, I mentioned already. I have to switch here. It's called the Speech Recognizer Python library front end, and then you can use multiple backends. So that library has in it the convenience of handling the microphone recording for you, and then delivering it to the specified back end that you want, and then giving you or you actually send it. It gives you the audio back. You send it to the back end you want, and then you get the speech to text. And so that's the overview. Now, to your question about how it does that, I had to go into their code to fix that. I think you weren't here. I was talking earlier, but I had to.
I was here for the leveling part. I understand that. I'm asking about this bit. Are you using the bit from your device, the is speech bit, to do something, or is that just?
Yeah.
Okay.
Yeah, that's what that I mentioned this earlier when I'm talking about the dynamic, you weren't here for the dynamic threshold, right? The dynamic threshold algorithm that they have in their code was not good enough because it could only ratchet down in level, not upward in noise. So I saw that speech flag was pretty well predicting, or not predicting, actually indicating when someone was speaking. And so that's the flag that code needed, because the code, the design of the code is, okay, there's a listen function, right? And I'll show you here, not that listen. Oh, wait, this isn't main. So there's a, oh wait, it's control T, listen. So when you listen, the system starts recording. Oh, here's the dynamic threshold. I'll show you some code with that. Let me find okay, here it is. So you say, with the microphone, listen to the person. And now the old code, I had these timeouts because this was, yeah, I should tell you, this is part of the story. And my intermediate solution was that I put both a phrase time limit, which is how long you can talk before it gives up and says, I can't take any, I can't listen to you anymore. And then also on the other end, there's another timeout flag that says, wait this long before, wait this long for somebody to start speaking. And because, the way noise in the room can change, I had to, with the old code, I put both of those, I set both of those to some number of seconds so that when this code executed, listen, it would either wait for like 10 seconds for someone to say something, and then only allow them to speak for 7 seconds, say, and then time out, and then go and do a check of the ambient noise level. That's how, the only way you could reliably adjust, because otherwise it would get caught in, okay, I'm listening, I hear something, but it's just noise to us, and it would fill up its buffer, and which could be many seconds. And so you're waiting there talking to the robot and it's not doing anything because it's stuck in this getting noise. So then the timeout would at least get it to come out of that, check the noise level, adjust the ambient to a higher level, then it could hear you because it would only listen to you above that number. You'd have to speak loud, over the noise in the room, right? So with this new flag, I edited the code inside listen essentially, and I'll show you that. I give it I pass in the function get is speech into the listen function. So now the listen system, whatever this is, large function, can call back get is speech. And when it uses that flag in its listening code, when it's starting to listen to you, it's starting to record. And as it's recording, it's adjusting the ambient. I turned the dynamic ambient noise back on, and it fixed it essentially, at least improved it. So when it's listening and you're not speaking, it's adjusting the ambient noise level, the energy threshold. So if the room gets louder, that number goes up. The room gets quieter, it goes down. Now, you have to get out of that loop somehow, right? Because when someone starts talking, you need to now take the recording and move it on, stop recording and give it to the next step. So the way it gets out of that loop, it breaks out, is if the level of audio jumps up above the threshold. That was the old way, didn't work completely because you could never get the threshold to go up. It would immediately break out of the loop and say, oh, someone's speaking now, even if it was noise, it doesn't know. now there's a flag called is speech. So now I put in, change the loop, change that conditional statement to if the noise level, if the energy level goes above above the threshold and the is speech flag is true, then break out of the loop. And so that's, and I'll show you if I can get to that init function, or let's see, F12. Or, that was, oh, F12 was finished now. Yes, or I need to go to, I had this open already. It's only 2 files open. Yeah. So this code here is in, like I said, the speech recognition. That wasn't right. Let's see, get speech recognition, and then in this init function, init file. So this is the speech recognition that is available from PyPy. So this is the big listen function. All right. So it's recording a single phrase, and it and like it says here, it waits until the audio has entered. This is the dynamic. I think it's sorry, you can't read this very well, but let me just. It's whatever. It's doing what I was just saying. It's in a loop here. While true, it's this loop, this lower loop. While true, so it's forever doing this. It's reading in from the stream coming from the microphone, and then it computes the energy here. I won't go into the details. This is the unmodified code, not Orange's code. So this is the original one. The original one would just say if energy is greater than the threshold, break out, and then process the speech. But if it's not greater, then it computes the new energy based on what it's the energy based on the amplitude of the incoming audio. So what I did is I modified this. I said and then that get speech or get is speech like this. So now I'm utilizing the hardware to vastly improve this small little bit of logic. So now this hardware has a reasonably reliable way of detecting speech. And when the energy is above the threshold, above the noise, and the speech flag, now this algorithm works pretty well. So it will continue to change adjust the energy level dynamically. This whole thing is inside the dynamic energy. And then it will be able to move that value up or down. So does that answer your question?
It does, thanks. Thoroughly.
And I was going to cover that anyway, so this wasn't the big side thing or anything. Any other questions about that? I think that's, yeah, we're almost out of time. So I wanted to, well, just as a side note, this VOSC thing is really, I just started this a few days ago, and it's working right out of the box. I mean, all the commands you'll hear today in my show and tell, it's all using local speech, VOSC, this VOSC thing. Now, this one is based on the CALDI. If you've heard of CALDI, and CALDI is a big research, and here's they tell you a little bit about the, oh, I'm sorry, you're not seeing this. They're coming up. Yep. LM adaptation. So, oh, it's in the draft. CALDI is this research, a research into speech recognition. It's a big effort. And actually the Pocket Sphinx or the Sphinx, the CMU Sphinx people are also, I think they're involved with Caldi, or they certainly utilize it. But Vosk uses Caldi, but this is designed for mobile applications. It's lightweight. It works on very small devices. The model size is only 50 megabytes, but it expands to 300 megabytes, I think. But they have multiple models. This is AI. These are speech models, and it runs in a small space. They're small model, and it's actually modifiable, which is really cool. In other words, you can actually adapt it by adjusting it, like a live adjustment. You can adjust at runtime the list of words to recognize, and you can also update our small models offline with language model from text. So you can actually retrain the language model from text, and then you can, with the big models, you can do more, but the big models are for something, a larger computer. What's interesting is I'm starting to learn. I mean, I'm trying to do so many robot things. I have as much time to learn like all the details about speech recognition science, right? But this is like a 1 minute course, which is explaining that there's 3 models typically used: acoustic model, language model, and phonetic dictionary. And so all these data sources are used for the model to work. Acoustic is sounds, naturally, and acoustic models, as Chris Albertson likes to say on in our group mailing list a lot, is you can't, it can only go so far with just acoustic model because it's very limited. It won't be able to discern differences between words that sound alike or anything like that. So then you need the language model. That's what words go together properly in our language or any language. You don't put certain words together, it doesn't make sense. So if the system thinks it heard that, that's a low probability that that's what the person really said. So if you try to say something that's a low probability, it won't get it. Like I misspelled one of my commands in my interpreters that I said, it was supposed to be show me your view. I wrote show me you view. So when I didn't want to rerun it, so I was just trying to say show me you view. And the system kept interpreting that as show me your view through this model, because it's like that's not proper English. I didn't learn that people say show me you view. So that's an interesting side effect of this. And then you have the phonetic dictionary model of the decomposition of words into sounds. Anyway, so that's the beginning, and there's a lot of stuff to study here. And I'll show you, if you want to learn more, there's the CMU Sphinx site has a bunch of, I have to read this myself, but it goes into depth about the science. I mean, not that long really, but you'll see here, it's talking about the models: acoustic, phonetic, language. And notice at the top of this, try our new library, VOS. So the people at CMU Sphinx are pointing to the one I am using. That made me decide I'm going to take that. I'm not going to use CMU Pocket Sphinx or anything, which is very old networks. Anyway, so that's something to look into. And then this is just this is the GitHub for speech recognition. Oh yeah, I was going to, if I need to use this is, I can use my tablet and share things here next time maybe. And I think so that's it. Any questions from online, or let me go back to,
I don't see anything on the chat for questions. Thank you, Alan, for all the links.
All right.
All right, so that will
right, thank
conclude
you,
the
Jim.
2 lectures. Since we have 3 show and tells, we'll do them after the business meeting. So for right now, we'll break for lunch.
Hey,
We're gonna pause the recording and we can continue the recording after the lunch break and the business meeting for the show and tells.
Lunch over.
Orange up to what it.
What time is lunch over, guys?
what's that?
What time will we end lunch?
We're gonna aim for like what, 12:45?
12:45, okay.
Yeah, I bought us a little more time.
We'll do business meeting and then Thomas is
Yeah,
first
my office
show and
is
tell, and then
Right next
you,
door, so.
and then
Okay.
Carl.
I had some stuff.
Oh, it's Carl?
There's Carl.
All right, people.
Carl.
Uh,
Right, wait.
All right.
That camera.
All right, guys, settle down. We're gonna start the meeting.
You are.
We are now gonna begin we're not gonna begin the business meeting, so
We're tiny.
welcome, everybody. We are back to in person. We will probably continue meeting in this conference room for the next meeting for the foreseeable future until something else happens.
More people.
Well, the good thing about this room is that we can reconfigure it depending on how many people come. We have a lot of seats on the sides and other tables, so we can reconfigure to accommodate more people or whatever.
Great, yes, you can rearrange. You can rearrange.
Yes, it can be reconfigured, rearranged.
Excellent.
Yeah. Okay, so the business meeting, Ron, our treasurer.
Yes, we haven't had the Treasury Report in a while.
Okay. January of 2021, in December, we started with $1,111.40. And we had a 2-year website bill of $195. And that's $97.50 per year because it's a 2-year, right?
Yeah.
Yeah. Okay, then we had statement of information for California, and that's done on the odd years. And that was $25. And then we had the RSSC.org name, and that's by GoDaddy. And that was $211.70, and that's for 5 years. And that's $42.34 a year.
We got lucky because last time we forgot to renew it and it expired for like 15 or 20 days and nobody got the domain. Nobody took the domain from us.
RSSC.org. Yeah, that was, you told me about that. That was, you were scared. You were like,
Yeah, I immediately.
yeah, like clicking like
Renew.
that was a near miss. I know that's a very,
We're left
four
with
letter.
$715.50, which means we spent $395.90.
Okay, now I have one question. The PayPal where we've been doing our dues, is that connected to our account or how does that work?
Yeah, it is.
It is connected,
Okay.
but it hasn't been transferred yet.
Okay,
That's you. Are you gonna do that, Ron? That's you should transfer it every once in a while. You can do that anytime. You're
Yeah, right, yeah.
what about our merch? Is that connected to the same thing?
No, the merch,
How does that work?
the merch is from that third-party company. And at this point, I made it all no profit on it. I specified, at cost. So all that merch is just provided by a third party, and the people buying it are paying me 100% of the cost, and none goes to us.
Okay.
We can
so-
change that. I just figured we don't need to inflate the prices even more. No one's gonna buy it. It's already
fine.
inflated, but we could, if you want, if you want, if the club wants, we could try to make a little money off it, but it won't be very much.
I mean, we've been doing okay. I mean, we don't really do much with the money other than end of the year party.
And pay for those
Yeah.
annual expenses and
Which we usually have enough with our dues. But I mean, it's up to you guys. If you guys want to monetize the merch,
What is that?
because we also have an online store that has T-shirts with mugs and
Oh, okay.
stickers and all kind of stuff with our logos on it. So that's what Jim is saying, that right now, we are just selling it at no profit. Whatever they charge us for the products, that's what we charge the user.
Oh,
So
okay.
we don't get any money from that. But if you guys feel like, we should be charging, I don't know, get a couple of bucks off of each piece, I don't know.
Oh, if
That's
you,
something that we could discuss.
if you haven't paid your dues, I mean, I'm here to take your money
yeah.
and there is no fee on that.
And this is, for 2022, if you haven't paid yet, even if like late 2021, people were paying for this year too, really.
Yeah.
Anything
Right,
after
because
like March.
Because it is yearly that we do our taxes and
Yeah.
our charity listing.
Oh, and right, by the way, if you do sign up for your, for email and text, which you can cancel, you can get 40% off of that cafe. It's called Cafe Press is where our store is. So I got the 40% off, then just cancel the, text message, whatever. I do that all the time. But then you can save some money on stuff because their prices are a little high, but I guess it's for novelty logoed items. It's probably going rate, I guess.
Yeah.
But it's cool. I should have brought my mug. I was thinking, I got all this robot stuff. I can't bring the mug. It'll probably get broken. But Thomas and I got the mug, and it's really good quality. The printout of this thing.
There's Thomas with the mug.
Oh, it is. Thank you, Thomas. Yeah, maybe these should be locked down.
Good looking. Oh, if the table wiggly?
Oh, it does have a lockdown.
Yeah, they do have a lock on the bottom of that.
Yeah, you flip this little switch on the one of the wheels.
Yeah,
this
that's
wheel
it.
right here. Yeah. It's only one closest to you, I think. I just did that one.
Okay, so now for the lectures, would you guys be okay with giving us update for the next lecture? Like, Alan, can you do like the next phase of the lecture that we're doing today?
I'd be happy to.
And Jim, will you be willing to give us like another update on red for next meeting?
Orange.
Orange?
Orange? Yeah.
Get the color right, man. Yeah,
Until we start, getting more into it and have different lectures.
yeah, well, I have a good segue because I have a speaker I'm lining up, Steve McKenzie,
perfect.
who is on the board of the Ross 2, one of the working groups or something. And he may know a lot about micro Ross too, but he was on vacation and I got a hold of him after he came back and he said, yeah, I'm definitely still willing, maybe next month. And he was asking actually for feedback from here, what topics in the Ross world that he might address. Like he's on the NAV2 board, I think. So NAV2, the navigation stack, for lack of a better term, of a system that Ross users use to navigate within Ross 2. It's called NAV2. That's the system for navigation, type locating yourself and all that, and navigation. He could talk about that. He could talk, I could ask him to talk about other topics like micro Ross or other things, even like migrating Ross 1 to Ross 2, which I'm working on now on something, which is a common thing people have to do. But any ideas?
I think wrote majority of navigation too. I think navigation should be a great topic for.
Yeah, that's, he recommend, I mean, he mentioned
Yeah,
nav
so that would
too.
be best.
He wrote it, right?
Yeah, he
So,
wrote it, so that I think that would be fantastic to hear him talk about that.
yeah, it's no better source than the author.
Yeah.
And at the level of, I mean, not all of us are that, proficient in ROS, so he could adjust to sort of a medium level, I would think, right? Yeah, or maybe he'll gauge the crowd and I'll just tell him, yeah, maybe start simple and then build up, because some of us have never used nav2 at all, and some of us have used it pretty well. Brian, right? You've been using it.
I don't know if I'm using it well, but I'm using it.
So we're all new then, I guess. Maybe Alan have you used nav2 a little bit?
Not yet. I haven't done mobile robots yet, so I'm watching your work really closely, and because Omnibot's eventually gonna have wheels and motors, and so I should bone up on that.
Okay, so good. So nav2 is, I'll tell him that we'd love to hear from the beginning, sell us on nav2 and how to use it. Okay, and that could be next month. That could be April.
There's chairs over there if you want.
But I'm willing to talk if he's not. If he's not talking, I can talk again on something else, on different,
Yeah,
another.
let them know that our two lectures are.
Yeah, 10
in
and
the
11
morning.
and 10 and 11.
If it's okay with you guys.
I think he wanted the 11 slot.
Okay. That's
So, which
fine.
would have been mine, I guess, or I don't know. I could switch with you at 10 if you don't have if you don't have something in 1 month and.
Yeah, no, yeah, it's, either time works. I also have a talk in the hopper for a conversational AI around GPT-J6B. So what goes into it, citations and stuff, so that could always fill up an hour between now and the end of the year.
Perfect. Yeah. Okay, so that's good. At least we have, for next month, talks and probably for a few coming up for that. Any questions? Any suggestions?
So do we know what the schedule is for next month? Like who's doing what?
So
Jim
Mackenzie
or
probably is
officially?
next month. I just have to,
Okay.
tell him that we, confirm it and the topic and stuff, but it's very likely he'll be able to
Yeah.
do it.
All right, and do you want the other slot, or do you want me to fill it with, given a choice, do you want whatever the next step is in ROS 2, or do you want to take a break and talk about GPT-J and conversational AI for a
Well,
bit?
the nav2 will be all ROS, so we probably do it. The other talk would be non-ROS.
Okay,
So do your GPT then?
sounds good.
I don't know, feels right, doesn't it?
Ron, did you have a question?
Well, if you wanted to talk to your robot, say from 100 to 200 feet away, it's really very simple.
Next meeting, April 9th.
You go to the 99 store and you buy a LED flashlight. Now, they have a chip in there, which is 3 terminals. And what it is a power supply for the voltage that you're working at. And one of them is an inductor. And the small flashlights like this run at a frequency of 250,000 hertz. So you have to modulate that, shoot it at your robot, and have a receiver that'll accept a 250,000 hertz modulation.
Didn't you make one from scratch one time that you showed it at one of our in-person meetings? Or
Yeah, well, you're right. Yeah, it's
Is that what you, is similar to that?
that's the part that actually does the work. This little 3 terminal thing, because it's actually a power supply. Because what it does is you can get down to 2 volts on the 2 batteries inside the thing, and it kicks us up to about 3 at that frequency. And just send the modulation through and receive the modulation, and then put your voice that you're sending to your robot system, and and at night it's good for over 300 feet.
And you're saying you can you can send a signal on there with your information along it, like your voice.
You modulate, amplitude modulation of that, because it makes its own carrier.
Carrier.
Yeah.
Well, it's not that unlike a little remote IR remote control, right?
Right.
That we, sometimes have on these Arduino robots. You can easily put an IR sensor and get a little remote. I mean, I bought a kit that came with that. So you could, but I don't know if the range wasn't, these are little, tiny little LEDs.
Right.
Your thing is more powerful.
Or you can buy the dollar, red laser that you get cats to follow.
Yeah.
Okay, it don't care. Because that 3-prong chip will make that power supply with that modulation, because it's, that's how it works.
Interesting.
It works with an inductor, so, the inductor will change the frequency.
Cool. Okay, can we talk about that after the risk?
Sure.
Meeting? Okay, so we have meetings. We have some lectures set up for especially for next month, and probably after that a few more. Thanks to Alan and Jim. What about getting back to contests? You guys want to set something up for maybe, I don't know, 4 months, 6 months?
3 years.
Any ideas on contest? If you guys want to?
I don't know, I was thinking, we'd wait, a couple of meetings in until
I know, but like
people, till people start getting ideas and projects going.
yeah, so if you
But yeah,
guys
we
have
could plan in
ideas
the future, right?
for the future, I mean, since we're back to in person.
Where would we be able to have these? Are we guaranteed the use of rooms here for?
We have like right outside a giant yard.
Outside.
use.
And this hallway seems pretty good. I just was checking out Orange in this hallway, and it's nice and open. This space is Orange immediately crashed into lots of things, got stuck and then twirled around violently. I'm like, turning it off, it's going out there. Because, it can get stuck on these wheels, and this is not a friendly room.
Or something like a contest or something, maybe we can move the table in the middle and use the center area.
Yeah, this would be okay for small robots, and here we'll get rid of the cables too, though, right?
Yeah, if it grows more, we still have access to the rooms next door, some of the rooms next door.
You mean at the other building?
Yeah, they're just filled with tables with, testing equipment and all that, so it's kind of hard to see over them.
Yeah.
But bigger area, but we'll see.
Because this is with this arrangement, it's a little hard for any robot, except, if this was all cleared out in the middle. But that hallway is pretty nice. We're allowed to use it.
And outdoor space is you have the light problem, right?
Outdoor would be good for some robots, like Magellan type, and I might be doing a robot that can handle outdoor because of a LiDAR that can handle. I have a LiDAR that works outside. So
You're saying the camera can't see outside very well?
But yeah, outside is more challenging, right? Because of the lighting, bright light, and I mean, I don't know. I'm not experienced in outdoor robotics. Anybody here should answer that more than me, but I know it's pretty hard because of that.
Yeah, where's Sergey?
Yeah, Sergey would know.
He's done a lot
Although
of
I'd like to
stuff.
get into that, honestly. So I'll use it. It's out back right here. Is that, or I'm sorry, in front. Front, is that where the?
I mean, I guess we keep it in front of.
Or where did you say?
Yeah, the challenge
Next to
with
the old
Corporation
building.
Yard is that we're still an active
was
site,
at-
so
yeah,
people working over
Cars
everything.
and all that.
Yeah.
police cars go by there fast and all that, you don't want to.
I didn't even like that. Oh, is that
Yeah,
what you were talking about outside,
I mean, anywhere.
anywhere? Oh,
So we still have access to all that area. We have the buildings, the outside backyard back there, you know, where we used to meet.
yeah,
So
that brick, it's kind of like red brick
it's
and
pretty nice out
is
there.
it nice?
Do a
We
step
did several,
navigator.
Sidewalk.
we did Robo Magellan competitions back there.
Oh, you
before.
did
Yeah,
years ago? Oh.
yeah, actually, it was, I think you won,
I
right?
edited, I wasn't here, but I edited my robot in it. Yeah.
That's right, yeah. You and your son, I think,
My
Nephew.
your nephew, yeah.
Justin. I didn't know you entered it. That's cool.
It's really good, yeah.
When was that? What, I
I
remember.
remember doing the Spark Fund back then, and so it was like without GPS, so it was, you know, a little harder because we were trying to meet the rules of the Spark Fund, and so you did it, you know.
Okay. Was
Dead
it with
Reckoning and stuff.
to the what?
Dead Reckoning.
Oh, the Dead Reckoning.
Yeah, it was pretty impressive though.
Well, but was that what the, I remember you doing seeing you guys do an outside thing, but that, or like going around a virtual track, but that wasn't Magellan. It didn't have the cone. You actually did one
You
with.
know, it wasn't Magellan, it was Magellan, like, it was outdoor. kind of
Okay, so that's the
going
one I
around
was
the
at.
sidewalk And,
Yeah, but it
I was there. Yeah, you guys did you
Yeah.
drove it around and then it learned and then it could do it
Yeah.
on its own.
that one.
That was great. Yeah, haven't done anything since then.
That was good.
That was very good. But yeah, outside eventually would be nice.
Yeah, so if you guys have any ideas for contests, you know, we can discuss that, whenever.
Yeah, there's the typical wall following and, you know, I've never done wall following. That's a pretty, you know,
The,
easy one to start with.
the color line following, all that kind of stuff, remember?
Color line, yeah, I've been there and done that. That was, you know, for me, it's something different.
How about get me a beer? How about get me a beer?
And that one could be for the end of the year, you know.
We still have the little mini refrigerator.
Oh,
over
we
there.
still have
Yeah,
that?
we still have all that, yeah.
Yeah, I would really like to see the grab me a beer done again, because eventually, you know, with enough time given.
Orange
people-
just needs an arm.
Yeah, orange needs an arm, which is a long it's a long, it's a long process.
Sounds like the name of a children's book. Orange needs an arm.
But
Wanna
Thomas,
write it?
Thomas is working
There
on
you
that
go.
too. Thomas wants to do get your beer. get a
Thomas
beer.
has the arm experience now.
Well, what I move robot.
The dynamics will last.
Body.
All right, do you guys have any other suggestions, anything you want to bring up during the business meeting?
A dance contest too.
A robot dance contest?
Yeah, those are fun.
Okay.
Robot dances with human contest.
Following the human.
Yeah, I want to work on, that's on my list, is to have Orange mimic you match your dance in mirror form.
Oh, there you go.
You-
Yeah.
Yeah, using.
Yeah, dance partner, right?
Yeah, it's a dance partner kind of thing.
You
We'll
don't have
do
to
like,
dance
so you
alone,
think
you
you
can
can
dance
dance,
with your
That's
grandma.
right. I know, it's kind of a nerd thing, but it's.
Well, it actually, I think it'd be very contagious.
Fun. Yeah, it's fun.
Yeah.
It's just using the tech to see what you can do with it, really.
Yep. And you guys want to bring anything else up on the business meeting, or should we move on to show and tell? Very good. All right. Thomas, you were first on the list.
All right, hi, everybody. Can you hear me okay?
Yep.
Good. I got two things to show you. Well, almost three, but let's start with two. First thing, I've just got the Oak D camera per the recommendation from Jim. Jim was very helpful in getting that started, and I got it working, and I'm not navigating with it, but you know, I'm preparing for that Get Me a Beer contest. So what I have here is the Oak D, and I've been using it for about 2 or 3 weeks now, and I got it set up on a tripod. How many of you have actually used the Oak D besides Jim? Anybody else in the house? One, I think I see one person.
No,
Yeah.
two.
Several of you then. So the Oak D has many different sample programs that it comes with, and one of them is to identify an object in 3D space. And so the object I wanted to identify was a beer. And I chose the little beers because I got a little arm, because I want the arm to grab the beer and give it to me. So I just, what's that?
It only works with 2-ounce beers.
Yeah. Yeah, so I don't have that part working, but I did get it working with Easy Robot. Of course, I figured out how to get the stream of data out of the OAK-D and into the Easy Robot software. So that's what I'm going to demo right away. Excuse me. So let me get the camera here pointing in the right direction. That, you can't see that, huh? Oh, everything's blurry. How about that? Let me try reoriented camera. Are we busy yet? Are we busy yet? There we go. Okay, that's as good as it's gonna get for now. I'm just gonna get, nah, this is gonna get. All right, so I have the bottle here and I'm gonna, I guess I gotta share my desktop. So I don't think I can do that all at the same time. So let's share the screen because I want to show you guys the software too.
Now you can do both because we'll still see the video and, you know, in desktop sharing mode, we see both desktop and the video. That's the normal side by side, you know, side by side.
Right, right.
And then we can adjust the size of which each one, or Alan can.
Okay, can you see my screen?
Yep.
Can you see it where it says the read OAK-D camera and start camera?
Yep.
Okay, so the first thing we'll do is start the OAK-D camera. And that's two windows. One is the data window and one is the actual camera window. And you can see it's already identifying the bottle. You can see the numbers change. This is the X, Y, and Z coordinates. Let me move that over so you can see it better. There. Now I'm only sending out the data for the bottle, nothing else, because that's all I wanted to identify. And it identifies it as a bottle until I turn it sideways. And then it becomes an airplane sometimes. But I don't. I don't pass that data. So then I can start reading it over here. And basically I'm just feeding this text into this program, that's all. And you can see it.
Did you write the bottle code? The bottle
I augmented, I just filtered it. No, I didn't write anything. This is all sample code. I'm just leaning on their, climbing on their shoulders to achieve my goal. And you can see the depth, which is the Z at the end, and the further I get away, the larger the number should get. Sometimes it doesn't. There you go, 1657. And it seems to jump in space, I guess.
It has a minimum, which is part of the problem. The minimum is if you go less than the minimum, it reads invalid, it goes up instead of down.
Yeah, yeah.
So 30 centimeters within that starts to get swirly.
You can see the numbers, the X, Y, the Y is kind of staying steady. Oh, we got an error on line 3. I hate that. Anyway, that's all. That's all for that one. And let me show you the next one. The next one is just some, yeah, this is one of the 10 projects. This is number 1 of the 10 projects that's on the front burner. Let me show you the other one that's on the front burner. I get my front burners are two things on.
What kind of stove do you have?
I know, really.
I need a stove for sure. So if you can pin the, who's running the video?
I am.
You are, all right. If you could pin the video of the, my other camera. Yeah, that one. Okay, I'm gonna go over there and I'll show you that.
Thomas wants to look muscular. He just puts that on. Good to go.
Can you hear me okay now?
Yep.
Okay, I'm gonna set this up. So this is the Vision robot, and this is actually a costume that I bought. And I bought a mask for it. The mask is separate. I made a few modifications, and this is the mask. And underneath the costume, I have a mannequin. You can see I painted it red. It doesn't quite match. I've got to work on that. Maybe Stephen Cook is good at matching colors, so maybe I'll have him help me on that. But the first thing I wanted to do was animate the head. So I put a pan and tilt mechanism on it. You have the pan here and the tilt here. And the next problem was, how do you connect this to that? Well, what I did was I put a big piece of Velcro, a big old piece of Velcro in the bottom and a big old piece of Velcro on top of here.
That works.
It's a light-type spin.
So let me put the camera into my tripod here. And let's give a quick demo.
Yeah.
I haven't got much of anything else hooked up here. So I'm just going to use the servo tester to turn it around. So that works pretty well. And this, the tilt has to be
When you put it on, it's too tall.
No, he.
zeroed in a little bit. 'Cause it doesn't- Yeah.
Oh, that's suiting.
That was good.
Matches.
All with a little piece of Velcro.
Yeah, that's true. That's not.
Just don't use hot glue, right?
That's not.
Take it in
It's
line.
it's great because it's light, so he doesn't have to.
Yeah.
You know.
Plus, it'll break free if he jams the servo or something.
Yeah.
It
I would have
won't-
put it
it
on a
won't-
styrofoam.
It won't stall out the servo and burn
But
it.
it's gonna have bobblehead problems.
Heavy,
Oh.
that when I put it on a mechanism like that, it was like, that was gonna fall.
You might want something with a
So that's
spring,
actually not a bad idea.
not a terrible.
He's got those beefy servos.
Yeah.
Anyway, guys, it's got a long way to go, but that's how far I've gotten. And that's about all I have to show for today.
Thank you, Thomas. Good old Thomas, right at the edge of the uncanny valley.
Thomas's workshop of horrors.
That is so funny.
I'm sorry, Tom, I hope you.
All right, thank you, Thomas.
I really think he should do a horror house.
Oh my God, wouldn't that be fun?
It's easier to create horrible, like scary humanoids
That's
than,
scary.
if you're in the uncanny valley, why not embrace it? It
I live in
makes
the
sense.
Uncanny Valley. I used to live in the Silicon Valley, but I gave it up to the Uncanny Valley.
Yeah.
I was just saying, Thomas, I think a great idea would be for you to go down embrace the uncanny valley and create a house of horrors. So that, then you could animate humanoids and they don't have to look realistic, they look evil.
Gardner.
Evil is easier. Evil is much easier to emulate.
Oh, they have that.
That's what they do, yeah.
They have a competition.
All the animatronics.
All right, thank you, Thomas.
Thank you.
Jim, you're up next.
All right, well, let's see, how are we gonna?
Are you gonna go in the hallway?
Yeah, the hallway. Do we have like a camera you can take around?
Sure.
You can,
Cell
you wanna
phone.
use my phone? I could
Or I can use my phone. Yeah,
just log into the Zoom tool on your phone.
I wasn't sure how we were gonna, yeah. No, that's
Either
fine.
one who wants to do it. You want to do it?
I could use my
Oh my
iPad too.
God.
Phone is probably fine though, right?
Yeah.
Opened up a can of worms asking that question.
So while he does that, I do have
Oh,
just
yeah.
one quick thing.
Yeah,
So Mitch and I got another gig for a TV show called The Rookie.
Oh, I want the
So,
phone.
so Tuesday, we're gonna go out there and drive the military robots for that TV show, yeah.
Oh, can I
No.
Cool, so it's gonna be cool, yeah. No,
Is
there's
that the
no
one
robot.
that's been used before? That kind of bomb squad looking
That
robot?
one, yeah. So they rented a lot for a lot of movies and TV shows, so we always go out there.
come?
and-
Nice.
Yeah, he's got two of them, so I drive one, he drives one. It's fun.
To what?
So it's
You play BattleBots with them.
Oh, no. You don't want to play, those
Well-
are $130,000 robots. I don't
I
think
need
you
to
want
talk
to
to Jim here, but I might
I
make
don't
you
know,
pay
those
for
BattleBots, they're pricey too.
Oh, instead of orange?
He said they're good expensive. Yeah.
I think.
Okay, good.
And the concept's good.
Join with video then.
Okay.
Alright, I gotta see more.
All right.
Oh, what, he's gonna project it.
Oh, no, I want to see the real thing. I mean, like, I could do that from home.
Yeah, you can. Yeah, look, it's a big hole.
Can you hear me, Thomas?
Yeah, I can hear you.
Not moving though.
Yeah.
Yeah, I like the pat and tilt mechanism, Thomas.
Yeah, it's pretty cool.
It's very beefy.
Well, it's
Robust.
bought it from Lynx, I think.
Yeah. I need to-
No, that was all Amazon.com.
Oh, well, several cities got one.
I think you sent the link to the kit that has all those metal,
Well, I mean,
aluminum extrusion.
Several City has a pan and tilt mechanism that we use for his arms on pan.
Okay.
I'll just demonstrate what they are. Two things to start with. The come here behavior, which we talked about, using audio, and then the follow me behavior, which like recorded and uploaded video. And right now, and then I might, if you want to see.
I can build two of them.
Yeah.
Could you do the plastic for me? Because my printer's still down.
I should be able to help you with that.
Okay, whatever
this
the
is-
cost is, let me know.
Okay. Yeah, so this is actually just the trainer. The other mechanism goes into the head.
I know what it goes into. You're trying to make your bot look a little more cooler.
Come here.
So do upgrade on there.
You got the video coming from the hallway and the audio coming from the classroom. It's kind of confusing. At Jim's phone that's running the video.
Okay, sorry about that. Okay. There it goes. Orange, follow me.
Okay, I will follow you.
No, it's gonna go to the closest person. So now you take over. See, it's the closest person. See, it shouldn't follow anybody who's further away than me, right, until we get about the same. The camera is not working, or it's not working quite as well as it's supposed to. Yeah, it followed her before. So yeah, you should give it a try. Just walk slowly if you're going around it, because it's kind of difficult to. There it goes. And what happens is it'll time out and go back, and now it'll find you again. All right, found Walter.
What's up?
He backs up too if he's too close. I know someone said you got to put a head on that. It's cute, something that's cute. Yeah, a difficult part of it is the turning. In fact, that I had to do first is just when it's stationary and just rotating to try to keep up with you. Yeah. So yeah, if multiple people are in the vision, it will go to the closest one. Because it can measure their depth, how far away they are. Yeah, so if you go further than me, unless it does. Yeah, if it doesn't see me, then it won't. But I can pick it up again, it will. Yeah, it can get confused if we're almost the same. And I can even give it other commands like, oh, it found Ben. Look at this. Orange, turn around. You can also give it, oh, I shouldn't talk. There. You can give it commands while it's even in that mode. And then when you're done, right, anyone else want to try? I mean, and when this thing is thinking, you don't speak. Don't expect it to hear you. The middle light is when someone's talking, but when you see like the pulsing thinking, multiple colors, then it like that's a thinking there. I mean, I guess once you know it, but when it goes just solid, it means it's triggered. The red one means voice. So the solid around it means some noise. The center one is voice. And then the thinking is like kind of multiple, two different colors back and forth. And then there's also another one talking. So let me let it talk.
Is there any blue?
Orange, status. Yeah, these are neopixels, so you can have any color you want. We can switch to the control screen so you can see.
Jim, can you hear me?
Yeah.
You ever think of putting in a telescoping tray and put some drinks or beers or sodas on it?
Yeah, well, yeah, I mean, I did that whole contest, or not contest, but delivering drinks I got like a 6-pack, a plastic 6-pack holder. And so you can, I wouldn't necessarily put 6 in there, it's too heavy, but maybe 1 or 2 drinks can go in like the fit. And I found a plastic 6-pack holder that fits perfectly on that tray. I looked it up on eBay, Amazon. So, and that was used at the famous aquarium incident where I had it all ready to go with the 6-pack. And then the lady tried to give me 2 drinks that didn't fit, or one of them didn't fit. It was this giant thing. I'm like, Americans drink too big of the sodas.
You got a product there you could sell, a robot that runs around finding people and giving them drinks.
Oh, fine. And Thomas says that you could find people and give them drinks. That's a great idea. Yeah. Or I could, yeah, something like maybe not cans of full soda, 6 of them, but maybe 2, or yeah, something smaller. That, and of course I can do something to deal with the weight, like put more in the back and rebalance it. Yeah. Oh, that if you want to see that behavior. Oh yeah. Now oh, now notice if he starts showing yellow, I put that in for the battery is getting a little lower. Yeah, so I can change these colors. Hello? Now let me show you something. Hello, orange. Oh wait, let's stop.
I think we could start the restaurant.
Orange, stop following me.
Sorry, I don't know about that.
Oh, I said stopped following me. So that, see, there's that whole language model thing. Orange, stop following me.
Okay, I will stop following you.
Orange, hi. Orange, hi. Orange, hi.
Hello there. Jim, it's nice to see you again.
Anybody can meet it now if you want. Just one person and visible at one time, and it will you can introduce yourself and it will remember you. But you'll be fair warning, your likeness will be captured in a database. I can delete it later.
Okay, how do we do this?
Just say orange.
Orange, hi.
But you got to wait until when it stops, it goes dark, when it stops undulating.
Orange, hi. Did it capture?
Try again.
Orange, hi.
Hello there.
Oh, just wait.
Jim, it's nice to see you.
I haven't been story yet.
Now you can that part didn't work. Maybe I forgot. Yeah, it is supposed to say, I don't think we've met before, but why don't you just say orange, my name is, and then give your name and wait till it's ready. Or say my name is, I think that'll work. I have to check.
Hello, your name is Philly way towards them.
Oop.
It's nice to meet you. Wait while I try to communicate your face to memory. Please, only you. Okay, next time try saying orange, hello, to check my memory.
I think we messed it up because the name said this. No, it thought we said some big, long thing. So the problem is me giving you the directions, he hears it. So try.
Oh, yeah.
It says my name is your, no, forget that. Just try it again. Just do it. Just wait till it's quiet and say orange. Okay.
Orange, my name is Trish.
Try again.
Orange, my name is Trish. Orange, my name is Trish.
Yeah, you might want to take your mask off.
Hello, Orange, my name is Trish.
Just say my name is.
My name is Trish.
You gotta say the name of the robot too.
Hello, Orange.
No, don't, just say the name of the robot and my name is, okay? It's very specific.
Sure. Orange, my name is Trish.
It's not getting the orange part.
I wonder if it's my voice, the level of my voice or something.
Say, yeah, try to make your orange like I'm saying orange. I could, couldn't I? But well, yeah, all right, we've tested that enough, so let me try. Orange, my name is Trish.
Hello, Trish. It's nice to meet you. Wait while I try to commit your face. Please, only you. Okay, next time try saying orange, hello, to check my memory.
Not yet, right?
Orange, hello. Orange, hello.
Orange, hello.
Yes.
You gotta talk like a robot.
Hello there. Trish, it's nice to see you again.
Yeah, so sorry, it takes a bit, but this is the first time or second time, maybe I've tried that demo. And the first time, I'm sorry? Yeah, or maybe third, because I want to query.
Orange, hello. Did you have to calibrate your voice?
No, it didn't. Here, stand in front of them and try it now.
Orange, hello.
Sorry, I don't know about that.
He got orange pillow. Yeah, take your mask off. I think masks are really not helping.
Orange, hello.
Sorry, I don't know about that.
Orange below. It's quite interesting.
But it doesn't know you, so say orange, my name is Walter, it's like that.
Orange, my name is Walter.
Hello, Walter. It's nice to meet you. Wait while I try to commit your facing memory. Please, only you. Okay, next time try saying orange, hello, to check my memory.
Orange, hello.
You might have to do it again.
Orange, hello. Orange, hello.
It's picking up other people talking. That's...
Sorry, I don't know about that.
You can still talk while it's here. Well, you can try even if it's lit up, just not when it's doing the pulsing.
Orange, hello.
Yeah, not when it's doing that thinking.
Orange, hello.
Hello there. Walter, it's nice to see you again.
Yeah, I work on the timing. It's just switching models because it's normally using a different, AI model, and it switches to the, it can't have them all in memory. So then it switches to the facial recognition one. But I can also show you, yeah, and if you want to see briefly the, let me tell it something. Orange, show me your view.
Okay.
It's the camera view with all the bounding boxes. So yeah, you can see different people in there and objects. It's not gonna know what this is probably. It'll know what this is though. Yeah, cell phone. And then yeah, I mean I have and then I do have at least one kill switch. Oh, I programmed it here, so I can say, orange, go to end of hall. Orange, go to end of hall. Oh wait, I was gonna drop.
Sorry, I don't know how to get there.
Orange, go to dock. Orange, go to dock.
Sorry, I don't know how to get there.
Dog, go to dog. See, I print this out so you can see what it knew, and then it's a lot of humor, and I mean, a lot of comedy. I can also type, as a fail-safe, I have a keyboard, I can just type a command in. So if really, and then the other solution is like a microphone right here. But Bluetooth is, yeah.
You tell or a home time.
Yeah, so I programmed it to the end of the hall as well, but given the time, did I kill the feed here? Geez,
Orange, go to dock.
Sorry, I don't know how to get there.
Orange, go recharge.
Sorry, I don't know about that.
Go reach? Jeez.
Can you just say a keyword? Orange charge.
Orange, go recharge.
I'm going to the recharge station.
Hey, Jim, you know, you have a lot of echo over there.
Yeah, this is the one other downside. This is the only downside of this nice hallway is the echo.
That may be giving you a lot of problems.
That is cool.
So a lot of this came with the Slam Tech technology. In fact, I think Gary, well, it has to find it. I think it was Gary. Did you say? Remember when? Yeah, or was it you? Maybe it was you. No, it's Alex. If that said it twirls around when you say go home because it's looking for its charging station, and it's got messed up or something.
You know,
Could be. Stop.
I've arrived.
All right, I hit a cancel. I canceled it. Yeah, it's getting yellow. That battery is starting to get low, and if it gets even lower, it'll say, "Jim, I need to recharge."
That's for the whole group, or just from the modules?
That's
Which batteries?
yeah, that's the main battery that for the whole robot. The only other battery really is this speaker. I need a better way to mount this. Yeah. Orange, go recharge.
I'm going to the recharge station.
How does it know where recharge is? Just the home coordinates, or is it actually looking for something?
Yeah, it's home coordinates first, then it looks for that 3D printed thing. I think it's getting confused. Maybe because of all of us. It's not in follow mode, is it? No. No, yeah, to debug this, you have to bring up the map and see what's going on, because it's obviously not, well, maybe it'll work eventually, but I haven't seen it. It normally will go right to this spot here.
It's not like a lot of it's here. Everybody stepped away from the recharge station.
Yeah, let's give it some room. It's lost in its map, and now there is a recovery for that.
What's that called?
Odometry. Yeah, that's odometry.
If there is, you think it have an idea of where it was.
It's getting closer. If you start to see it turn slowly, then it's at its home. Yeah, it's at its home now. It's looking for those two little caves.
I'm going to see what's behind
It can see 360. I did it earlier today and it worked here, so it's
Does the battery feel low?
oh no, I don't think it's low enough yet to cause a problem.
Should have happened there.
Yeah, it's obvious. This is the first.
It's looking for that term. White box.
It's looking for those two little cavities.
Might be the lighting on those things. Is it sensing that with ultrasonic sensors or is it?
No, LiDAR. Yeah, it's adjusting a little bit. May not be close enough to, that should be about, oh yeah, I should have made the home or, no, it should be, yeah, it should, that is the home. Oh, wait, I should have made the home closer to the dock, probably, a little closer.
So home is out there where it's hot.
No, yeah, home was somewhere a few feet in front. Oh, this thing. Oh, wow. Orange, stop.
I've arrived.
Let's try one more time here. Let me. Orange, go to dock. Oh, yeah. Orange, go recharge. Orange, go recharge.
I'm going to the recharge station.
No, you know what?
When you push it, that mess up the odometry.
No, it doesn't mess it up as long as the wheels are moving. I think it's too far. It worked before, but I may have to, or it's lost. Yeah, I would turn the light out. A fluorescent light is not good for us.
It's hard
at home, didn't it?
They get headaches from fluorescent lights.
All right, I'm gonna try something else. Orange, relocate yourself.
Sorry, I don't know about that.
This is Orange, do relocalization.
Sorry, I don't know about that.
I have to look at my command list. All right, we can stop. Anyway, thank you. All right, signing up.
That was really good.
Yeah. But it's using it's using the facial recognition sample. Yeah. Oh.
There's a time when they can.
Yeah.
You gotta meet the microphone.
Okay.
Jim, your phone's still on. You need to hang up.
I thought I can do this. I'm sorry.
Are you still connected? Then we got an echo.
Jim, your phone is still on. You're still connected on your phone. Yeah.
And can you move him? There you go. Thanks, Ben.
I think we lost audio from the conference room. It's muted. The conference room is muted.
Well, then go. I know, that's what I'm trying to find. Got something there.
I hear you now.
Okay, that's Carl. Okay, you're up.
All right. Well, I was gonna say the hybrid mode worked pretty well with the conference camera, the audio up until the remote unit, and just the past couple glitches actually worked really well. So I'd say that sitting here at home really feels the same as if we had an in-person meeting. So that conference camera is really great and did a good job. So I was just going to talk briefly about the first robotics FRC competitions. Most of you are probably familiar with this, but they're in their competition season now. So First Robotics is probably one of the biggest competition organizations out there. It was started by Dean Kamen, who's famous for the Segway. And the idea was to elevate robotics competitions to kind of the same level of sports things. So they have a Lego version, they have a VEX version called the FTC, and then the FRC is the big robot. So and that's the competition that's going on now. They get the contest rules like in December or so, and then they have 6 weeks to build these robots. So I'll show a quick video. One of the regional competitions is going on now in Orange County, and then there's an LA one up in El Segundo in about 3 or 4 weeks. So the Long Beach, typically the FRC or high school teams, the city of Long Beach has at least 3. So there's one at Cabrillo High School, one at Poly High School, and then what I've been helping them out is at the Sato Academy, which is just about 3 blocks from the Cal State Long Beach where you guys are.
That's right. That's, yeah, the State Academy of Math.
I have one there.
Yeah.
It's right here in the corner.
So,
Maybe more. So.
Volunteer?
If you want to connect with them, I have the information.
Yeah, you should
Trying to share my screen, but I'm not seeing it right now. I apologize. Give me a second here.
They were looking for volunteers.
Yeah, they're always looking for mentors. All 3 schools have very few mentors. So Poly had 1 when I talked to him. Sato has myself, and then another guy who's kind of an Uber mentor. He's been doing it for a long time. And then not sure about Cabrillo, judging by their team.
How much? What kind of time do you spend there, Carl? And what day? On a weekend? So
normally during the year they're meeting once a week. Then closer, once the competition rules are released, they stepped it up to a couple, 2 times, 3 times a week. I'm just going once a week, and then but the build period's always been pretty frenetic. And then the competition, these competitions are 3-day weekends. So I'm sorry, I'm having problems. I can't get into Zoom right now. It's just. Am I sharing my screen?
It's a little bit of commitment to do it.
No, you're not, Carl.
All right.
We can see you.
Okay, here we go. Okay, sorry about that. I haven't done presentation for us. I'm still trying to figure this out. Okay, got it. And then I'm going to optimize for video. sound. All right. So I'll show you the video in a second, but let me just preface it by saying that basically for these competitions, they run 2.5 minutes. The first 30 seconds is autonomous, and then the last 2 minutes is teleoperated. Basically, they have each team has 1 robot. Each competition has 6 robots running. They have 2. They have a red alliance and a blue alliance. And for the preliminary runs, they just randomly assign 3 teams to be on each alliance. So there's 6 robots out there. There's 3 red robots, 3 blue robots. And when they get down to the finals, the kids actually pick the teams that they want to be on. So this is one of the preliminary rounds. I'll go ahead and run it. So first 30 seconds autonomous, they get points for backing up. And then if they can grab balls and shoot them in the target. This year, every year the competition is different. If you look up Rapid React FRC on the internet, you can see all the rules and videos and stuff for this year. The name of the game this year is Rapid React. And they basically, they have a goal in the middle, kind of like a basketball hoop. They can shoot balls in the top for the most points and then shoot it down at the bottom for the next level of points. And then at the very end, there's these monkey bars over in the corners. And if they can hang on the monkey bars, they get a lot of points. So that's
And they get more points if they shoot the balls of their own color, and they detract points if they shoot balls of the other color.
There you go. Yeah.
This first match of the morning, drivers behind the lines in 3, 2, 1, go!
Our last spate of qualification matches begins now.
Autonomous,
We go
bunch of
into
back up,
qualification match 77 as the human player for red scores in the upper hub in autonomous. Teams attempting to pick up extra cargo from the field.
Fell this one off, so now the teleoperator stepped forward. Now they're all driving.
14-12, the score early here as drivers take control
The one
of
that
their
got
robots.
hung up on the monkey bar in the back is the team I'm working
Titanium
with.
Robotics picking up cargo
was
from
accidental.
their human player terminal as 1868 the Space Cookies launch from range and make a volley into the upper hub. Each cargo scored in the upper hub during teleop is worth 2 points. In the lower hub, it's worth 1. These alliances are trying to score 20 total cargo during the match to earn a cargo bonus ranking point, which will help them rank highly and have the opportunity to pick their partners for this afternoon's playoff matches. Momentum trying to slow down the high-scoring Griffitrons, checking them with their bumpers, making sure that they are not comfortable there.
You can see some of the launchers are automated. They
1868,
have
the Space Cookies
retro
shooting from
reflective
range again, a
peak
little bit
on
wide.
the middle
The score
thing.
with 75
They have
seconds
these
to go
neat
is
laser
30 to
guided
16.
things that gives them
Red
a
has the
centroid
advantage
to them,
so
they can
far.
aim the turrets and actually aim
We are
and shoot the
seeing
balls with it.
lots
So the good
more
robots have
defense
these
here than we did
automated
yesterday.
turrets. They just collect balls
1160.
and then they automatically
Making
launch them
another
in.
good shot, Titanium Robotics trying
Most
to
of the teams
extend
don't have
their
that.
lead. Tiki Techs
They're more
moving
defensive
up to the fender at the bottom of the hub there, shooting for the upper hub but missing. Poly Robotics engaged in battle with 1868 the Space Cookies, trying to make it difficult for them to pick up the blue cargo that they need to close
Typically
this
teams
gap.
that don't have their
With
robots
35
working very
seconds
well
left,
just
the
play
score
defense.
is
They try to block the other
36
robots.
to 16 for red as Poly Robotics begins climbing.
There's the last 30-second warning, so now
angle
anyone
rungs.
who can climb the monkey bars
Their
is
opponents
rapidly
in
trying to
blue
run
look
over
to
and
be going
get
for
on the
their
monkey
own
bars.
rungs as we get to 20 seconds left in the match. Up to 15 points available
The higher you get
per
on the monkey
team
bars,
in that
the
hangar
more
zone
points you
if
get.
they can make it to the traversal bar.
So
The traversal rung,
that one guy climbed all the way to the
still
top bar.
activity at the hub as Griffitrons attempt to score more to extend their
There you
lead.
go.
We will have your results anon.
There you go.
Is that a robot that's here?
So Carl, during the autonomous stage, it was shooting, but is it like how much do they achieve with the, is it like the autonomous stage is kind of experimental?
Yeah, it's so typically very few teams do a lot. So I saw one team where they actually went after a ball and then launched it in. So they and that is pretty rare. I mean, there was 42 teams at this competition. It's just finishing now. 42 teams there, and only 1 or 2 actually autonomously go after and pick up a ball. So it's pretty unusual. You know, again, it's the problem is that, you know, it's such a short time frame that some of the, you know, better staff teams, you know, with more mentors and all that can do more of the autonomous things. But for a lot of these high school kids, there's just not enough time to really perfect a solution to do that. So.
Very hard.
Thank you, Carl.
Yeah, and that's going on now. There's tons of competitions, tons of videos online. These things are streaming like crazy on YouTube.
It's happening now, Carl?
Yeah, this competition is just in the finals right now. So I was there the first 2 days, and then I wasn't there today. So, but then like again in like 3 weeks or in LA up by El Segundo. The Orange County one, actually, because of COVID, they're not allowing any guests there. I don't know what they'll do with the LA ones, because that's in a few weeks. So maybe they'll open it up. Yeah.
But did you have a lot of fun? I mean, it's exciting, and you have a lot of fun, and it's exciting for you to do that.
Yeah, it's fun. It's a lot of work, you know. Obviously, the kids are great. You know, I mean, they're really interested, and they do, you know, as much as they can. The events are very exciting. I mean, you can hear the music going, and they have an announcer and all that. So they do a really good job hosting the events. So, and then, like I said, even if the robot's not working right, the one for the team I'm on, the intake mechanism ball broke in one of their first matches. So they basically are just doing defense and climbing that first rung the rest of the competition. So, but, you know, they have a role that, you know, they can do that defensive play, you know, and so there's a good part of that. So, you know, if you have an alliance with a team that can shoot balls, and they need somebody to defend them against the other players. So.
You know, it's such an interesting layout, and it seems very exciting with the robots and the game arena. You would think that would be on TV, but somehow I don't really see it on the news or anything, you know?
Yeah, I guess that part of it, you know, the vision for it isn't quite gone forward, but yeah, I mean, this regional, like I said, 42 teams, largely from California. There's one from Vegas, one from Colorado, one from Turkey. You know, I don't know how they traveled out and all that, but there they are. Yeah, and then one from Hawaii, and then one from Mexico. Yeah, just in this regional alone. So, yeah, it's so yeah, within the realm of high school robotics, it's a pretty big deal.
I'm surprised they had a team from Turkey, because usually they don't like to have out-of-country teams on the same.
Yeah, I have no idea what how that all came together.
American teams. Think of the final.
Another interesting thing is the main controller. You know, they have a device called the Robo Rio is their main controller, and what's interesting is safety is a big deal, and they all have Wi-Fi connections back to laptops that run joysticks at the teleoperation station. The reason why they have this whole complex custom setup for that is that they have central control. So so if there's a problem, they can shut all the robots down from the central control thing. So their controller for all the robots is designed so that they can you know, activate and deactivate things. And they have a whole series of lights and things like that, so they can tell if once everyone's connected, that's when they actually start the game, because everybody has to connect up to the central system and all that. So there's a lot of thoughts going in over the years. There's a good amount of flexibility in what they can build. The bases are standard. They can only use approved motors, and there's quite a wide variety of motors, you know, brushless brush, the different speeds and torques and things like that, but you can't really come in with an unapproved motor. Most of the other stuff can be done pretty custom. So.
All right, Dallas.
I need to drop off, guys. Thanks, Carl. Thanks, everybody. We'll see you next week in Riverside.
Yeah, next Saturday.
Thanks for coming.
Next month, I'm going to try to be there in person. Take care, guys. Bye.
Bye.
See you, Tom.
See you later, Carl.
Yep.
All right. So
Thanks, Carl.
thank you, Carl. That was a fun presentation. Good to see that all the robotics communities are starting to ramp up again in person. Starting to do events and all that kind of stuff. It's a good, refreshing step from what we've been doing. So yeah, that concludes the meeting for our first in-person meeting after
2 years and 1 month.
Yeah, 2 years. and 1
Yeah.
month of online. Thank you, everybody, for coming. If anybody else has anything to add, you can stop the Zoom, I guess.